So I just want to say that I welcome you very much for this conference. It's the third in a series, and as you know, it's about physical and chemical methodologies for the conservation and restoration of cultural heritage. This year, the conference is dedicated to two English researchers, Raymond White, who I've been told is still alive and living in Chile, and John Mills, who passed away recently, I think, and who are, of course, you all know them. I didn't know them because I'm not in the field, but apparently they are very important for your subject, and in fact they wrote the sort of basic textbook on it, which appeared already maybe 30 years ago, and this whose title is Organic Chemistry of Museum Objects. Okay, so, and also this, I have the impression that this time the organizers, that I thank very heartily, decided to invite a lot of Italian researchers who are active not in Italy but abroad. So we have people from Chicago, from UK, and maybe Germany, and so on. So this is, I think, adds more interest to the, and also illustrates the strength of the Italian science in this subject. So I'm very happy that this, and I hope that Gennaro will accept to do it next year as well, because this is becoming one of the core activities of this small academy. So I think that I will leave you, and I don't want to bother you anymore, but I think it's a duty to thank Francesca Casadio, Gennaro Marino, who is the man behind the thing, and Antonio Sgamellotti, who is a colleague from Accademia dei Lincei, and who is going to chair this first section. So I don't bother you anymore, and I I ask Antonio to coordinate the first section, and I try to listen to a few of your lectures, not all of them, I'm sorry. Thank you very much. So, tu devi far sedere lo speaker lì, e poi quello o sta in piedi oppure mette le slide.
We are in time. We are 5 minutes in advance. As a chairperson, I will be strict in respecting the time, because you know we are also in remote. And so it's very well to respect the time. 5 minutes before the end of your time, I will make you some kind of sign to say that you have still 5 minutes. I will not spend too much time in presenting the speakers, and the reason that they are so well known that it's not necessary. I want to say as much as time. Concerning the questions, I would say that they can be made at the end of the session. So, in time, I would say with 3 minutes in advance, I give the microphone to Marika Spring, who is an important person in the National Gallery, being the responsible of the scientific department of National Gallery. That is, in my opinion, one of, I would say, my favorite galleries. Marika, to you.
Thank you, Antonio, for those kind words of introduction. Can everybody hear me okay? Great. So it's a great pleasure to be here today at this meeting dedicated to my former colleagues, John Mills and Raymond White, both of whom spent their careers at the National Gallery. They're known, of course, for their pioneering work in the 1960s and 1970s on the organic chemistry of museum objects. And Raymond still visits us every now and then and is just as interested in the GCMS as he ever was. So I'm going to range a bit more widely in my talk to set their work in the context of the history of research on the materials of paintings at the National Gallery, not giving a comprehensive history, but touching on some points, and also, given the topic of this meeting, picking out connections and collaborations over the years with research in Italy in the same discipline. I'm going to be drawing especially on the work of another former colleague, Joe Kirby, published firstly in this article in the Burlington magazine, and secondly in another article about to be published in the proceedings of a seminar in 2021 organised by Utrecht University on the history of conservation science in the post-World War II period. And quite a few others of my past colleagues have also touched on this subject, especially in relation to conservation. So Susanna Avery-Quash, and I'll refer to some of her articles in our curatorial team, and also David Saunders, another former colleague. The first director of the National Gallery, Sir Charles Eastlake, was an artist by background, but was also remarkable because of his great interest in the conservation of the paintings under his care, and also on research into the materials and techniques. So this kind of research has really been embedded in the gallery's work right from the very beginning. And he was known mainly for his expertise in Italian painting. But the first volume of his book, Materials for a History of Oil Painting, published in 1847, was devoted to the history of oil painting in the Netherlands, and specifically the special characteristics of the medium used by the Van Eycks. And his methodology was a thorough review of the historic documentary sources that shed light on the technique and materials. And this topic was endorsed by the Fine Arts Commission in the UK, who in fact commissioned quite a number of studies in this period on historical painting technique. The aim of Eastlake's work was to try to understand why these paintings had survived in such good condition, with a view to promoting better oil painting practices in the British artists of that time, and I think this is sort of a legacy of Reynolds and his experiments. Eastlake knew Mary Philadelphia Merrifield, who's another important figure in this field of research at that time. And he mentions in his preface that the copies she had obtained of manuscripts in Italian libraries would be of great assistance to him in investigating the history of oil painting in Italy in his second volume, which was published posthumously in 1869. Mary Merrifield had already published the first English translation of Cennino Cennini, and then in autumn 1845 was given government funding to go to Italy for 6 months, again sponsored by the Fine Arts Commission, to collect historical source materials in the archives, specifically about oil painting in Italy. And this resulted in her 2-volume original treatises on the art of painting, published in 1849, which is still a valuable reference work today. And her volumes functioned as annotated editions of various collected treatises, and were therefore a complementary counterpart to Eastlake's book, which instead used documentary sources to construct an overall narrative on the history of oil painting, and indeed they referenced each other at many points. By the time Eastlake was writing, it was already known that oil was being used in Northern Europe as a painting medium, well before Vasari stated that Van Eyck had invented this technique. The case that Eastlake was making was instead that Van Eyck and his contemporaries owed their pivotal place in the history of oil painting to some special improvements, especially modifications to the oil through the method of preparation. And he drew on a wide variety of historical documentary sources on painting materials for this work, an approach that is still very much part of the methodology of my department today. And many of these were only just coming to light from the archives and being published or translated into English for the first time as he was working on his book. And he himself seems to have been the first to refer to the Strasbourg and De Kettem manuscripts in relation to oils. He also studied the Arnolfini portrait closely with a magnifying glass to deduce what he could about the working properties of the paint, and then rationalized these observations with a detailed analysis of the recipes and instructions in the documentary sources for preparation of the oils. it's interesting to compare Eastlake's conclusions with what we know today from analyses with the techniques that we now have available to us. In the 1990s, Raymond White, working with Jenny Pils, analysed almost all of our early Netherlandish paintings for the scholarly catalogue, using first FTIR to determine the class of material, and then GCMS to identify the type of oil and also any pre-treatment, as in the recipes that Eastlake was surveying, and also the addition of any resins, as Eastlake had suggested might have been done for glazes. And indeed, in general, both linseed and walnut oils were found, and they had sometimes been pre-polymerized or heat-bodied. And it was also quite common to find a little pine resin had been added to red and green glazes. Eastlake devoted a lot of space in his book to the many recipes for preparing or clarifying the oil. And he was the first to refer to the Strasbourg manuscript and considered this recipe to encompass the chief improvements which were introduced with the Flemish system of oil painting, as he said. He also concluded that the chief dryer which they used in preparing the oils or varnishes appears to have been white copperas, which is zinc sulfate, on the basis that it is included in recipes in both the Strasbourg and De Kettem manuscripts. Until recently, this conclusion was considered irrelevant to our modern investigations, but we then found, first through SEM EDX analysis, that Van Dyck did indeed add zinc sulfate to his paints, as we can see here in the EDX spectrum from a sample from the Arnolfini portrait. And then more recently, we have been able to map its presence with XRF, as in the zinc XRF map here. So there was truth in Eastlake's conclusions, and this also shows the importance of documentary source research to highlight materials we haven't yet discovered. Eastlake did reference the work of some scientists in his book, including some early experiments by the Frenchman de Saussure on the drying and yellowing of oils. But his consultations with scientists on behalf of the National Gallery focused mainly on preventive conservation, including commissioning experiments from Michael Faraday, no less, on how to protect the paintings from the highly polluted air in Trafalgar Square. Faraday was also one of the authors of the 1853 report of the Parliamentary Select Committee set up in response to the cleaning controversy, where it was suggested that chemists be appointed to investigate cleaning mechanisms. Eastlake even suggested as early as 1845 that scientists could be useful for other research on the materials of paintings, especially those in the geological field, but it would actually be another 80 years before the first scientist was appointed. It was not until after the First World War that museums and galleries in the UK began to consider actually employing scientists. The British Museum Scientific Laboratory was set up in 1920 with Alexander Scott as its first head to deal with problems with their collection that had arisen from poor storage conditions during the war. Harold Plenderleith was employed in 1924, and given the lack of scientists in other institutions, he was consulted by them on the care of paintings, and including by the National Gallery. He was involved in a meeting of scientists and curators organised by the National Gallery director in the late 1920s to advise on the problem of the flaking of paint on panel paintings, and subsequently published an article on the subject in the first volume of Technical Studies in the Field of the Fine Arts, featuring the gallery's panel you see here by Verrocchio. The National Gallery was one of the places visited by William Burroughs from the Fogg Art Museum at Harvard when he travelled around Europe with his portable X-ray equipment, and he made X-rays of around 40 paintings, 40 of our paintings in 1927, and these are the earliest X-rays we have of our paintings. The 1930 conference in Rome on the examination and conservation of works of art, organised by the International Museums Office of the League of Nations, was a significant stimulus for advancement of our field. And many museum laboratories were set up around this time, including that at the National Gallery, which was established in 1934 with the employment of the physicist Ian Rawlins as the first scientific advisor. And his work focused mainly on technical imaging, including X-radiography with the apparatus seen here in 1934. And also infrared photography, and this near-infrared detail of the hands of Arnolfini, probably made with the camera shown here, shows very well the changes made to the underdrawing. It seems that the curators quickly took up the opportunities offered by technical imaging, since already in 1937, Philip Pouncey, assistant keeper at the National Gallery from 1934 to 45, published an article where X-rays were used to good effect to argue for two artists, probably Costa and Mainieri, having been involved in the production of the Palestrozzi. And this was on the basis of the very different style of the first version hidden beneath the surface, as in the Virgin's head seen here in the article. The description of the X-ray details was very thorough, but Pouncey didn't notice this small feature here, circled in red. And when we finally made an X-ray of the whole altarpiece in 2014, we realized that this was one of 6 cherub heads surrounding the Virgin, but subsequently painted out. During the Second World War, Ian Rawlins was taken up with organising the safe storage of the National Gallery collection outside London, but during that period, many paintings were cleaned. Back in Trafalgar Square, an exhibition of cleaned pictures was organised in 1947, which was so popular it had to be extended. The small book explained the treatment and also included some notes about technique. At the same time, however, there were strong criticisms in the press about some of the treatments. The National Gallery therefore asked an independent committee chaired by Dr. Weaver of Trinity College in Oxford, Paul Coremans from Belgium, and George Stout from the US to look into the matter. And this led to the Weaver report, which did not find any evidence for damage, but was significant for the scientific department, since one of its recommendations was that a research chemist should be employed to conduct research into cleaning and improved varnishes. Anthony Werner was taken on in this role in 1948, and here you see the small chemistry laboratory that was set up. And Joyce Plesters joined in 1949 as work on the examination of paint cross-sections also developed, initially with the brass microscope shown in the slide, which Joe Kirby tells me is what Joyce used for the photos of the cross-sections in her seminal article published in 1956 in Studies in Conservation. And included here is a sample from Pollaiolo's St. Sebastian altarpiece, which we're re-examining at the moment, and I've indicated it with the red square. And at this time, we find a card for each sample in our conservation dossiers with Joyce's description and a small black and white photo of the sample, which he then carefully tinted with watercolours. And here is also a new digital image of the same sample, which has lasted very well since it was made in 1953. At this time, the pigment identification was made with microchemical tests, and heating or solvent tests were used for the binding medium. Venetian paintings were Joyce's great love, and in the late 1960s, she collaborated with Lorenzo Lazzarini, helping to set up the laboratory of San Gregorio in Venice, and then subsequently collaborating on the analysis of paintings by Tintoretto during the restoration of the Church of the Madonna dell'Orto after the flood. And this was published in 1972 in the preprints of the Lisbon IIC Congress. In fact, she examined 25 paintings by the artist over her career, including all of those in the National Gallery. But going back now to 1951, this was when 2 Nuffield scholars joined the scientific department for 3 years, one of whom was John Mills. And during that time, he did pioneering work on the composition of damar and mastic resins using paper chromatography, showing how it was possible to distinguish between them. And I've used a slide borrowed from Joe Kirby here, which summarises his main publications that came from this initial work. He returned to the gallery permanently in 1961, and soon afterwards the funding was found to buy the gallery's first gas chromatography equipment, shown here. And the work John did with it on the fatty acid composition of dried oil paint films was again pioneering, and no one had done this before in any field. This allowed him to obtain results such as this on the panel from Museums Week in 1968, where the egg tempera medium used for Piero's baptism was distinguished from the oil medium used for Piero's St. Michael, and which could be specifically identified as walnut oil. The late 1970s saw another significant advancement, which was the purchase of the Kratos MS-25 mass spectrometer, allowing John and Raymond White, who had joined the gallery in the later 60s, to carry out GCMS. And I'm not sure that this is actually the Kratos, but it is representative anyway, since Raymond's mallet is because all of the earlier equipment required a lot of attention. So we take the kind of analyses I showed earlier on Netherlandish painting somewhat for granted now, but this work by John and Raymond really laid the foundations for it. And it's worth bearing in mind when looking at any older results in the technical bulletins that any published before about the mid-1980s would have come from GC analysis only, so they only report the type of oil, because before the GCMS was acquired, it wasn't possible to say whether the oil was heat-bodied or not. Going back again to pigment analysis, another photograph from Museums Week in 1968 shows the milliprobe X-ray fluorescence analysis instrument lent to the National Gallery by Professor Teddy Hall from the Archaeometry Laboratory at Oxford, showing that non-invasive methods of pigment analysis were being explored even then. The instrument had a beam of only 1 millimetre or so, but in the end it lacked the necessary sensitivity and it was little used on paintings. By 1974, the department was able to carry out elemental analysis directly on cross-sections after acquiring a laser microspectral analyzer made by Carl Zeiss. And here Joyce Plesters is working at the microscope that was part of the instrument. And the beam was only about 10 microns, allowing the cross-section to be analysed layer by layer, a major advance on the previous microchemical tests. And this remained in use until SEM EDX was acquired in the mid-1980s. And by this time, we also had X-ray powder diffraction bought in 1980, which was much used for identifying different types of lead tin yellow, for example, and different forms of calcium sulfate in gesso grounds. All the research that was being produced with these new instruments was one motivation behind Gary Thompson's decision to launch the National Gallery Technical Bulletin, the first issue appearing in 1977. It perhaps also gave the freedom to publish in a truly multidisciplinary way. And even with this first volume, there are articles written by scientists, conservators, and art historians in collaboration. And our work is still rooted in this approach, where the application of science is not for its own sake, but firmly directed at understanding the National Gallery's collection. And we also still often combine the scientific analysis with the study of documentary sources, as Eastlake did so long ago. Of course, we've continued to update our equipment, but I'm going to end here rather than taking us up to the present day, as I promised in my title, as you'll get a flavour of that from the talk coming up very soon by my colleague Marta Melchiorre. Thank you.
Thank you very much, Marika. We are in advance. So if there are any questions, comments, they are welcome. Otherwise, we pass to the next speaker. And next speaker is, I don't need to introduce saying anything. This is Francesca Casadio, so well known, which will be bringing some air from Chicago. Francesca, the microphone is yours.
Thank you, Antonio. Thank you to the Academia for hosting us. And I'm gonna move us on here. If I can see the cursor, great.
Beautiful title.
Thank you. Yes, it's a pleasure to speak to you today, and great to come, although a little humbling, after Marika Spring and hearing about the detailed history of the scientific laboratory at the National Gallery, which I'll touch upon just very briefly. My interest in studying the history really stems from desire to understand this aspect of interdisciplinary collaboration between art historians, conservators, and scientific experts in the advancement of our knowledge and preservation of works of art. And certainly in this, I've been intrigued by this TED Talk, where often we focus on what we're doing, and so the temptation is to stay at the brushstrokes. But really, when we can achieve this integration of knowledge, and of knowledge spanning from the humanistic to the scientific, that, in my opinion, is where the breakthroughs really happen. So I'm going to start in the 20th century, and here you see a view of the Art Institute, the institution where I work in Chicago, at its early foundings. And in my own understanding about the history of conservation science and what is now being termed by Sven Dupre, professor at Utrecht, that Marika also mentioned, the scientific conservation. I found some of this papers and books that you see here very, very helpful. And I also am very grateful that Marika already has mentioned Merrifield and Plesters, and I want to also draw your attention to the fact that some attention now to also the female contributors to the beginnings of the discipline are being evoked. The other thing that to me was really interesting in studying the history was realizing that really there's been parallels and some specific peculiarities in the developments in Europe, where really the scientists were called in the Beaux-Arts school to aid artists in making paintings that would last and that would have a beautiful technique. So studying the techniques of the old masters to inform the artists of today. And so there is this combination of the scientific analysis with accurate reconstructions and historical reconstructions of materials. There is a trend in the study of the historical manuals. And already Marika has evoked the first scientific labs in museums that were established. And the 20s also are a time when a lot of this attention of scientific tools is directed to the identifications of fakes and forgeries. And there was this interesting case on the Franz Hals where already you can see the beginning of the spitting of the eye of the connoisseur versus the science, which will be a theme that that recurs and that still is somehow unresolved in our practice of today. When it's a bad day, when it's a good day, it all works out really well. And some of this influence, some of the scientists from Europe came to the States in the 1920s at the University of Pennsylvania in Philadelphia. De Wilt was hired to studying the science of paintings. And Marika also evoked this really interesting moment from the 1920s to the 1940s, together with the establishment of the League of Nations and that became UNESCO, this institute for the International Institute of Intellectual Collaboration was established at the Palais Royal in Paris. And it was really for intellectual collaboration internationally of every type. Part of the interest of this group was also on whether there should be scientific expertise focused on the study of works of art. And you can see that in the French documents that are just recently being studied, some of the questions that we still ask ourselves today were already surfaced in terms of, is it actually useful to apply scientific methods for the preservation of works of art? Should there be an international organization organizing this type of knowledge? And what would be the techniques that would be most applicable? And so as a result of this questions in the professional and intellectual community, as well as historical forces that have been studied recently more in depth by Marco Cardinali, amongst other, in the 1930s, and it's been mentioned before, the International Museum Office of the League of Nations held a conference in Rome where a number of scientists and curators and prominent art historians and connoisseurs debated whether scientific tools could in fact be of interest and value to the field. And once again, I want to underline how in the header, for those of you who don't speak Italian, there is mention of un gruppo di uomini celebri, and how if we look around even in this hall today, the gender balance is definitely much better nowadays, if you ask me. And then as a result of this conference, which was held in Italy, but really had much more fruitful seeds internationally, a flurry of establishment of various museum laboratories happened. Fortunately, Marika gave all the specifics about the UK, and then we'll move to the States just in a little bit. But a number of important publications to really solidify this field of knowledge and of inquiry were established. Among them, the Technische Mitteilungen für Malerei in the 39s and the Technical Studies in the Field of Fine Arts at Harvard, and then, of course, very, very influential, the National Gallery Technical Bulletin. I will have to get some water.
Oh, yes.
Sorry.
Sorry, I was supposed to offer you water. Sorry.
Yeah, no.
I am not a very good chairperson.
It was certainly very influential for me as a young student of chemistry, where I almost read it as a magazine because, the National Gallery Technical Bulletin, that is, because of this incredible ability of bridging the gap with a language that was understandable both by the specialists but also by curious readers. And as I'm studying more about the origins of scientific labs in museums, I've also realized that a lot of the history that we are focusing on is very centralized in North America and Europe. But more and more, it would be important to also look at the periphery. And at a very interesting conference last month at the Prado, I also discovered that in the 1910s, in Mexico City, the Museum of Fine Arts in Mexico had a scientific lab. There was a lab in Mumbai that was established also in the 30s. And even in Italy, there were a number of gabinetti scientifici in Naples, in the Museo di Capodimonte, as well as in Milan. They were vying for predominance until the Istituto Centrale del Restauro was established. And very interestingly, books were published about scientific examinations of work of art, and I was quite struck by this Renato Mancia, who proposed really the Uber machine that had X-rays and UV and microscopes and raking light all in one room for the investigation of works of art. Of course, in the 30s, it's in the interwar period is also a time when European history is quite fraught. And so thanks to the work of Andreas Burmeister, who was the head of the Dörner Institute in Munich, here is a photograph that he presented recently about the opening of the Dörner Institute, where sometimes the study of pigments and artist materials was also promoted as understanding the true technique of the true artist with respect to the art of the degenerate artist. So sometimes there are also some darker shadows in institutions that did really well, that did really good in terms of advancing our knowledge of these materials. And then in 1939, the Istituto Centrale del Restauro in Rome was also established at a time where of course, the fascist regime was ruling in Italy. And these were really foundational labs that have continued to have quite an influence in our field, and also interesting to look at these historical images and see how our practices have changed significantly in the study of works of art. Moving in this transatlantic, I will do quite a bit of this over to the States. The other thing that is interesting to realize is that while in Europe, initially the scientists are working in the Beaux-Arts Academy in the 19th century up until those first museum labs, in the States it's really with the 1928 establishment of the Fogg lab at the Harvard Art Museums that scientific research in museums and art starts, together with, in association very much with the efforts of Burroughs, Alan Burroughs, who, as Marika mentioned, traveled really across the States and Europe to X-ray works of art. And this was quite revelatory, because truly, if you think about X-rays, it was a way for the scientists to give art historians new ways of seeing. For the first time, they could see below the works of art. And this is correspondence of Burroughs to Forbes. And it's interesting because he says the practice in reading X-rays, which we have, puts us automatically in a position in advance of others. And so this identification, the ability to have scientific tools at their disposal gave them somehow a competitive edge, is also interesting when we consider this bigger framework of the inevitable power dynamics between art historians and scientists that still working in institutions sometimes we experience. So if we think about the 20th century, if one could make a summative assessment of the origins to a certain extent, what I can see is that in the States, more heritage science happened in museums, where in Europe it was a little bit more, at least at the start, in academia. In the UK is a hybrid model, because quite a few labs were established at the time. And the focus of research is really on authentication, in the study of pigments, the cleaning controversies, and those sparring debates about the eye versus chemistries started at the same time. If we move to the 21st century, and here it sort of mirrors a little bit the history of my own institution that was founded in 1893, and only in the 50s had its first conservatory and had to wait until the 2000s to have a scientist. And certainly in the United States in the 21st century, the role of one foundation, the Andrew W. Mellon Foundation, is quite influential. And I put some numbers there. Over about 12 years, they gave approximately 53 million to establish a number of scientific positions in laboratories and postdoctoral fellowships and faculty positions. So of course, as we've seen, since the 20s, there were scientists in museums, but really we owe it to the Mellon Foundation to double pretty much the size of this enterprise. And what I certainly have observed myself is that certainly the 21st century saw an explosion of science in museums in the States, but academic research is not very developed. While in Europe, there's been a proliferation of really valuable PhD programs, and the growth in terms of staff, scientific staff at museums, has not mirrored what has happened in the US, hence the diaspora that certainly many Italian scientists have experienced. The other innovation has been in the mid-search of teens of the 21st century, the idea of diffuse hubs for science. And so mobile labs, and here you see the one at the Met, and the one at Northwestern University that I established. And of course, we took a page, this I gave as a note to you, Antonio, from the Italian MoLab, but before then even, the French had the Labobus. Of course, with time, the size of the bus becomes smaller and smaller. And here was a project that we did at the Musée Picasso in Antibes, where the MoLab team was very generous to come with their equipment. And this is, again, a 1980s slide from the French investigation of the paintings. And this was in 2011 when we were there with MoLab. And in the rest of the talk, I really want to focus on the kind of changes that we've seen in the field. And so one example is that now, while science was behind the scenes, more and more we see scientific research and conservation in view of the public. Certainly for me, the most radical example of this is the depot in Rotterdam, where this is actually a guided tour. The public is given lab coats, and they can walk into the conservation studios, they can walk into storage, and the entire collection is available. I'm waiting with much anticipation, and Lucia maybe will tell us more about this, about V&As, where supposedly the public will be able to engage and handle the objects in storage. And then there's been so much done, and again, I picked these examples because of our friends here in the room today, to somehow normalize the science in museum, and in fact also disseminate it to the public. Here is the Operation Night Watch with modern day XRF analyzer in a glass box where the public really can see scientists at work at the museum. Another very innovative project, although it got mixed reviews, was creating a whole exhibition at the National Gallery that we visited with Marika in 2020, where basically the science was the pièce de résistance of the whole exhibition. And this really has made this work much more in the public sphere. And I have just very quickly, I will go through a series of slides from the Art Institute, again, mostly to honor some of my colleagues in the room, Federica Pozzi, who worked on this exhibition at the Art Institute Renoir, but also for Van Gogh and all the way to Cézanne. And what's interesting is really, I'm bringing these examples because, and the next one, this is an example of digital labels, so digital interactives in the galleries that explain the science of paintings in very sort of simple terms with cross sections and some analysis. And I think that this is useful because when you do evaluation, which we have done, here you see an example of a small intervention in the galleries where we had evaluators observe the visitors, and not only about 90% of the visitors take the time to scroll through all the information and read the information, but 98% went back and looked at the art. And considering that there are scientific papers that have measured that the average dwell time of a person in front of a work of art is 17 seconds, and if you have a digital label, they engage with the label for 2 or 3 minutes and then they go back. To some extent, with the technical analysis, we have definitely increased the engagement with the work significantly. Another thing that we have measured that was a surprise is that through explaining the technical details of execution of a work of art, these are watercolors by John Singer Sargent. Then we also had qualitative interviews with the public, and this element of empathy came out pretty strongly, and to me it was really fascinating because our investigations into the process make the public relate with how hard it is sometimes to realize in the works what you see, more than just walking through the exhibition. The other significant impact that I'm seeing is in publishing. And so, do you all remember the appendix? Or sometimes the science in the footnotes? That was about 20 years ago. It still sometimes happens. But certainly with the 21st century, we've seen, and for us in Chicago, definitely in the digital catalog sphere, a much more broad understanding of authorship and contributorship. And so here's an early digital catalog of our Impressionist collection, and the scientists are all contributors. And then fast forward 2016, the scientists who actually did work on the Gauguins are authors. And in monographic catalogs, then we also have multiple authors for an essay that is now not at the back of the book, but actually in the middle of the book. So that definitely has been great progress. Leading up to a really interesting experiment. If you're not familiar with it, I recommend that you take a look at this 10-year experiment that Peter Miller ran at Barr Graduate Center, really from the point of view of the historians and the art historians, to look at what he called cultures of conservation, and conservation as a human science, and really realizing that despite this this closeness of practices, we're still very siloed. So really that started me thinking about the difference between a humanist authoritative voice and the more collaborative approach that we have in the sciences to authorship. And that to some extent, I've called it an activist view of collaborative authorship. And I've also started to think about when is it that collaboration with art historians from a scientific perspective work, and when does it not work? And in my mind, and these are sort of some early graphs to pictorialize this, it's probably when the science has an impact in unraveling what happens, what meets the eye, what happens at the surface of the work, that we have the most impact. So if we look at brushstrokes to breakthroughs, these are some of the trends that I am seeing in terms of what was front of mind in the 1920s and what today is really the evolution. And I'm going to pick just a few. I think this pitting of the eye versus chemistry, where now more and more there are multiple experts working under one roof. To some extent, from the wet chemical tests that Marika has evoked, to microinvasive and non-invasive analysis, and also from X-ray films now to computational imaging, hyperspectral data cubes, fusion of this data. So I want to conclude just with a few notes that some of you who were at the Gordon conference maybe remember. I became curious to do a research about what are the publishing practices in object-based art history. And this is, I collected about 80 responses, and you can see quite well distributed between scientists, conservators, curators, the gender balance that reflects what is in the profession right now, mostly US and North America with some contributions, and a good spread between museums, government, and university. And if you look at what are the factors that really favor collaboration, the idea of looking at objects together, something that is possible often in these museum labs, and the flattening of hierarchies. Nobody's doing research for somebody else. We're doing research with somebody else, are two of the main factors for success. Certainly, you would not be surprised that the most important instrument development are those that create images, and the macro XRF is evoked very often, although there are sometimes when you poll art historians, they also say there's no instrument that is really groundbreaking. It's really the art historical questions all that matter. And in terms of the type of publication that overwhelmingly is considered a successful example of scholarship, the museum exhibition catalog really is evoked as one of those that is more successful in that respect. And the National Gallery Technical Bulletin also evoked many times. I'm taking advantage of the fact that Marika was ahead of time, because I see I'm reaching my 30 minutes. So we can go a little quickly here, but certainly this idea of bridging the language gap is important, because there's still some difficulty in understanding the language, the technical language that we use. I will not dwell too much on the tribes, but I kept this because these are some of the quotes that I received in 2022, and we go back to the eye versus chemistry. And in Bernard Berenson's foreword to Daniel Townsend, The Materials and Technique of Medieval Paintings, you can see the quote, "I regard all questions of technique as ancillary to the aesthetic experience." And Erwin Panofsky, a search of iconic theories of art history, pretty much also dismissed any scientific inquiry as something that sure answers a question, but not really an art historical question. When things work, though, and the discipline, I think, is very, very healthy because of this combination of museum science and academic science, is the ability to see in different ways, which happens all the time when you put together experts from various disciplines. And certainly there are many, many examples of this publications. What I would argue for is, if we can please stop calling it technical art history. It served a purpose at the time when the discipline was established. I believe that in the 21st century, calling this object studies or material studies in visual culture would serve us better, because if we make a niche of art history with technical art history being already a discipline that is struggling for its own existence, I don't think we serve our field too well. And I was really struck by this writings by Isabel Stengers that calls it an ecology of practices. And there's a really interesting quote there where when she talks about ecology of practice, she mentioned to feel the borders, that you have to approach the other discipline with questions that they will accept as relevant so that they don't go into a defense mode. And that was really, really interesting to think of this ecology of practice as a tool for thinking and for thinking across disciplinary boundaries. So I in all this various ways that we have called our field interdisciplinary, multidisciplinary, I owe it to Anna Holing, who teaches at UCL now, this concept of post-discipline. So in looking at the history of scientific labs in museums, I am wishing for a post-disciplinary world where it doesn't matter if you're a scientist or an art historian. We're really all looking at works of art with passion and with our expertise and advancing knowledge of how they're made, what they mean, and how we can preserve it for the future. Thank you.
Thank you very much, Francesca. You touched, in my opinion, three important items. The evolution of the collaboration among scientists, curators, and restorers. The new approach of scientists towards visitors in museum, and also the language innovations. Thank you for your contribution.
Thank you.
Now we pass to the third contribution of this first part of the morning. Is a contribution from remote. We go to London, and I ask Marta Melchiorre Di Crescenzo of the National Gallery to take the microphone and to speak to us.
Thank you, Professor Sgamelotti, and good morning, everyone, from a rather rainy London. I'm going to try and share the screen that we tried before, and it was working, and I think it is still working. Thanks a lot to the organizer of the conference, and it is really a pleasure to be here and have the chance to talk about some of the work that I do as a senior scientist at the National Gallery. But before diving into the world of old master paintings, I've been asked to spend a couple of words on the training I received in Italy, highlighting aspects of it that helped me to excel in this area. Well, I'm one of the very first students who graduated at bachelor and master level in conservation science at Ca' Foscari University in Venice. And despite some hiccups that were inevitable for a program that was that new back then, I think that the program, for which I need to thank the memory of Professor Biscontin, included the right balance of hardcore scientific topics, art history and conservation studio practice, which was indeed an excellent way to interact with real objects, learn how to assess their condition, take samples, test materials and methods for conservation, which are all important skills for a conservation scientist, although probably not enough to excel in this field at an international level. Still at Ca' Foscari, I then completed a PhD on conservation issues of contemporary murals, a research line that around 2008 and 2009 when I started was still new for the group working with Professor Zendri, and that until then she had mainly focused on topics related to stone and built heritage. And I think it is the experience I got during my PhD, shaping my own research, hands-on analytical equipment, working with a variety of Italian partners, proactively setting up new collaborations at international level, that in my case was with the UPV in Spain. So all of these made me a resilient researcher, able to work on different types of collections at international level, as I did not only at the gallery, but also at the British Museum and historic royal palaces. But thinking of my current role, which requires an excellent knowledge of painting materials and techniques to properly contextualize the result of scientific research, I should probably also thank the extra time that I invested carrying out internships in painting conservation studios, plus my particular interest in what I'm going to call now technical art history, although Francesca Casadio don't like it. I nurtured this passion I had working with Professor Teresa Perusini, which was the supervisor of my bachelor and master thesis, and which led to a postdoctoral fellowship on polychrome wooden sculptures, during which I certainly strengthened my skills into the analysis of paint samples, which is still a part of my job here at the gallery, together with the use of spectroscopic imaging techniques, reflectance imaging spectroscopy in particular, for which has become the main point of reference at the gallery. And during my 7 years now within this amazing organization, I contributed to numerous projects, either to inform conservation activities, to feed into curatorial research for exhibition and cataloging programs. And I was so lucky that one of the very first paintings I investigated with reflectance imaging spectroscopy was Leonardo's Virgin of the Rocks. And it has been so extraordinary being able to contribute to the discovery of more figures belonging to the first composition that Leonardo had initially drawn on the panel and then abandoned in favor of the well-known painting. And it would be very tempting to talk about this today, but since the research has been thoroughly presented and published, I decided to talk about more recent work, which showcases the integration of spectroscopic imaging techniques and analysis of samples into the investigation of paintings. My first case study is the portrait of Charles William Lambton, popularly known as the Red Boy, painted by Lawrence. This is one of the most loved images of British art and the first painting ever to be included on a British postage stamp. It perfectly exemplifies how scientific analysis was critical in supporting decisions taken during the conservation treatment. Preliminary cleaning tests had indeed shown that some of the red passages of the boy's suit were sensitive to solvents, and indeed the combined investigation of cross-sections and surface scrapings highlighted the presence of medium-rich surface glazes likely to include the same natural resins found in the non-original varnish layers. And another reason why I'm showing these quite spectacular, I would say, cross-sections is that they revealed the presence of an extremely thin, even yellow layer underneath the red paint, with SEM-EDX and Raman analysis indicating this contains chrome yellow in the form of lead chromate sulfate. And in 1825, when the portrait was executed, chrome yellow was still a relatively new pigment, although not completely unknown to other British artists active around that time, such as Turner and Constable. And Lawrence was keen to use new painting materials, but equally concerned about their stability. So he had a collaboration with the British chemist and pigment manufacturer George Field, who tested pigments for him. And there are some notes in Field's journal books dated around 1815, which record that he had tested samples received from Lawrence, which turned out to be chrome yellow. And if this was not interesting enough, XRF scanning revealed the presence of chromium under large expanses of the boy's clothes, confirming that the thin yellow layer seen in the cross-sections was not accidental, but some yellow paint initially used by Lawrence for the boy's suit, which is extremely relevant because historical accounts suggest that Lawrence had originally painted the boy in yellow. So we were able to prove this. Now, traveling both in space and time, I'm going to present some very recent work carried out on these wonderful 15th century Cassoni panels depicting the story of David by the Florentine artist Francesco Pesellino. These were treated recently in preparation of a forthcoming free exhibition dedicated to this artist who was celebrated in his lifetime, but is now often overlooked. And in this case, the complementary use of XRF scanning and reflectance imaging spectroscopy made it possible not only to identify and map most of Pesellino's painting materials non-invasively, but also to fully appreciate his remarkable skills of painter of ceremonial splendor and exquisite detail. And I'm proud to say that some of the images I'm presenting today will feature in a video as part of the exhibition. This is one of the risk maps showing the distribution of azurite as identified from this spectrum from the sky. And the map was gathered from the signature features of the pigment seen in the shortwave infrared. And it shows the use of azurite not only in the sky, but also in the hills, in the farm landscapes, the rivers, and apparently some tiny, tiny dots in the foreground area. And if we look closely at one of these areas, we see how Pesellino used indeed touches of azurite in the central part of some flowers. A lovely detail, but so easy to miss when looking at the full-scale painting. And here I'm quickly showing the copper XRF map, where this detail is completely lost among the many copper-rich passages depicting the grass and leaves. And Pesellino's remarkable skills are also evident in his lavish and very precise use of gold and silver leaf, here highlighted by the respective XRF elemental maps. And again, if we look closer, we see that the silver leaf is not only used in the knight's armors, but also in details such as the bridle mouthpieces and the horseshoes. And hopefully you also appreciate how small some of these pieces are. And equally small are the gold leaf pieces in the dress of this young girl. And we should remember that the standard practice for an artist of that time would have been to apply a relatively large piece of gold leaf on red ball and then paint the dress on top of it, leaving out the decorative pattern. Here instead, Pesellino applies small individual pieces of gold, one for each feather on red ball. And I particularly like the false color reflectance image on the right because it works in a complementary way to the XRF map, not only showing the gold leaf pieces, but also in very bright yellow, their edges where they have been covered by paint to define the final feather-shaped decorations. And now going back to the silver leaf, so you might have already noticed that this was rather abraded and tarnished. So technical images such as the false color reflectance image here in the center were particularly useful to highlight and visualize fine, dark paint lines that Pesellino used to depict the armor details, and also a dark paint used for the armor shadows, so to give the metal a three-dimensional effect. And interestingly, this dark infrared absorbing paint was also found to contain low levels of copper. Much higher levels of copper were seen in other paint applications, which also look dark on the painting surface, but do not absorb in the infrared images, and were seemingly used with a different function to embellish the metal leaf. And we can appreciate this here in a detail from the brocade dress of one of the ladies, where it is just possible to recognize few pigment particles, which suggest that the paint was originally green and has altered with time. So these observations prompted the second phase of the investigation, aimed at clarifying the composition of the copper-containing paint applications through analysis of paint samples. And today I'm presenting only some initial results of this that is proving to be a very challenging investigation. So here is a cross-section from the same dress of the lady we were just looking at. And you can see it is almost impossible to distinguish, and therefore even to identify the particles of the copper-based pigment that has been included in the paint. This seems to have highly interacted with the paint binding medium, resulting in the overall darkened appearance of the paint. I'm not sure we will ever be able to say what pigment was originally included in these decorative paint passages, but it might be relevant to point out that the green copper mineral pigment identified in the paint for the trees consists of rounded particles of malachite with some angular copper sulfate, some silicon potassium feldspar, and a couple of particles of azurite. So I'm mentioning this not only because it could be interesting to establish the geological source and provenance of the pigment, but also perhaps to explain its reactivity with the binding medium when applied over gold leaf, if of course this was the green pigment used there. And a couple of highly deteriorated copper-rich particles were also seen in a sample from one of the paint applications, looking dark in both the visible and infrared images, and seen to register less strongly in the copper XRF map. And this paint primarily consists of carbon black, confirming the hypothesis that it was always meant to be dark, and therefore had a modeling function rather than a decorative one. And once again, it was not possible to properly identify the copper-based compound added as a minor component to the paint. And to date, it is not clear whether it was used to slightly shift the color of the paint or maybe to act as a seccative, with this latter option pointing out the potential selective use of an oil binding medium for this paint application of a metal leaf in a work that otherwise is painted in egg tempera. And with these slightly open questions, I would like to thank the various colleagues that contributed to the material I presented in the slides, and in particular two other Italian scientists who have been working with me, Eugenia Guedes da Filicaia, who is currently completing a PhD in partnership between Bristol University and the National Gallery, and who has been doing a maternity cover with us. And she had been carrying out the FTIR and organic analysis of the Pesolino samples, and also Silvia Rita Mato from the Courtauld, who helped us with Raman analysis of the Lawrence. And before, thank you all for your attention, I wanted to finish, if possible, with a small observation about what is going on in Italy. I mean, we know that the academic level at Italian level is amazing. We all train there. But this is indeed what I found yesterday looking at the website of Ca' Foscari University. So this suggests that scientists owning a master's degree in conservation science, and also to some extent those owning a degree at bachelor level, have access to a number of jobs. And this is something that I would like to discuss potentially in the round table at the end of the conference, because certainly it was not an option when I and my peers graduated, nor even when I completed my PhD now about 11 years ago. So I'm really glad this has become an option, and I hope that my scientists who graduated during these years and will continue to graduate could actually find suitable jobs in the field outside academy and without leaving their country. So, and I thank you again for your attention.
Thank you, Marta, for your speech and also for your very interesting comment that I will comment later on at the end of the section this morning. Thank you very much. There is any, we have some time, so I mean, if there is, oh, Marco?
Yes, I have a question, Marta. This is Thank you, Marta, for your talk. This is Marco Leona, and I'll actually be chairing the
I'm sorry,
round-
but I cannot hear, so I think there is a problem with the microphone.
Can you hear me now?
Now it's fine. Yes, yes, I can.
Thank you for your talk. This is Marco Leona. I will be chairing the session, the round table, so I will certainly remark on your comments and make that a point for discussion. I wanted to ask you a question on the cassone, though. So the details in silver leaf with the painted decoration on top always beg the question of how the committant, the patrons, and the people who looked at that object, which was supposed to be durable, perceived the silver leaf, which would have, I imagine, tarnished quite soon. And so is there any evidence, anything in your studies or in archival textual material that talks about that? I encountered a problem, for instance, in Japanese art, where often the moon or the crest of waves are completely black. And what I know from that field and the critique there is that people didn't care. It happened very soon, and they made peace with that, which would have, of course, created an image completely unlike the real world. So just that thought for you, and if you know anything about that.
So that is a very interesting remark. So what I can say is that we see the use of this dark paint with a modeling function to give the metal leaf a three-dimensional effect. So I think that although the tarnishing would have happened quite soon, there was an idea that there was need of defining a three-dimensional shape. I'm not sure how much they were aware of how everything would have worked together as soon as the silver leaves would tarnish. But this is something that it would be very interesting to look into. Things that we notice is that there are a lot of decorative patterns, mainly on the gold leaf, but also sometimes on the silver leaf. Those are certainly present. And as far as the gold leaf, some of the patterns were used indeed to catch the light in a specific way, so to create, again, specific optical effect when the object was illuminated. Less so on the silver leaf. So maybe there was already awareness that the metal would have soon change, is reflecting properties.
Thank you, Marta. I think that now we can conclude the first session of the morning, and we deserve a break. So shall we start or wait? Okay, may I introduce Lucia Borgio? I know Lucia Borgio since long time. I just want to say to her one thing that happened. Do you remember, Lucia, how many times we came to the Victoria Albert Museum to study the luster decoration by Mastro Giorgio? Many times.
Yes.
Once we were in France, it was raining, cats and dogs. I was swearing, saying, why do I have to go to the bloody Victoria Museum to study something that was decorated in Gubbio, 20 kilometers from Perugia? That is life. Now the microphone is yours, Lucia.
Thank you. Good morning, everyone. It's a real pleasure to be here and be reunited with many of the cultural heritage Italian diaspora. It doesn't happen very often. For those of you who don't know the institution I work for, the Victoria Albert Museum, it is one of the few institutions in the UK to have a dedicated team of scientists in-house working on collection-related issues, but also addressing research questions and providing access and support to external partners and requesters. The lab is relatively small, but it's very equipment dense, and it's intensively used. Here on the left, you can see a list of all the major scientific instruments that we have, and many of them were upgraded recently thanks to a UKRI grant 3 years ago. And one of the greatest strengths that we have, and it was touched on earlier today, this morning, by the other speakers, is that there is such a close collaboration between conservators, curators, and scientists, which is a lot more pervasive than I have witnessed anywhere else, and we really treasure it. It's what I call the magic triangle, which later on transforms. I will show you how it transforms into a magic polygon, possibly, or with many more sides than 3. Historically, a lot of the work that we do is routine, or what is normally called routine, responding to queries from conservators and curators to enable the V&A's public programs, so exhibitions and loans and display, but also collection care and scholarship issues. And at the same time, though, we do collaborate with other collections and researchers from other institutions to advance the field of heritage science and developing new methodologies and making new discoveries. What you see on the screen is just some examples from the last 18 months, but there is so much more happening at the same time. I just didn't have enough space on the slide, unless I wanted to have very tiny, tiny, tiny photos. The fact that much of what we do can be described as routine, in inverted commas, does not preclude discoveries and groundbreaking surprises. Many of the most recent discoveries at the V&A, such as the ones that you see on the screen at the moment, happened during the course of what has started as a routine analytical campaign. What's the secret ingredients behind these discoveries? Is not state-of-the-art equipment, is not new methodologies, is not money, although obviously all 3 counts quite a lot. I think it's the attitude of the scientists. It's the curiosity that we have mixed with a hefty dose of skepticism. And I always tell my students never to trust themselves, always question everything, never assume anything, do not have any preconceptions, because you need to start from a clean slate. But it's also the humility of not thinking that we are the experts and we have all the answers, although many times, most of the times, we actually are the experts and we do have many of the answers, but don't start from that position from the very beginning. And last but not least, hunger. Hunger for new things, at least that's true for me. heritage science should never become a boring day job, 9 to 5. This way you can keep your outlook fresh and start every project with a clean slate, without assumptions, ready to be surprised and ready to enjoy the process. As I implied earlier, the separation between collection care and official, proper research is less marked than you would expect. And today I will touch on 2 projects, 2 examples that did not start as bona fide projects in terms of research, but stem from our routine care collection activities. And please bear in mind that this is unpublished, ongoing work, so do not reuse any of the images or concepts that you see on the screen until it's been published, because obviously we wouldn't be, or the powers that be at the V&A wouldn't be very happy. The first set of objects I'm going to discuss here is anything but routine. It's the V&A Foster Codices, which is Leonardo da Vinci's own notebooks. They're very small, as you can tell from the image of me with them. And they contain handwritten notes, like in this page, or architectural and technical drawings, as well as preparatory sketches for Leonardo's own paintings. And the reason why we were asked to look at the codices was to understand the materials that Leonardo used to write and draw, and inform conservation and display decisions. And in particular, we needed to qualify the risks of lending the manuscripts for an exhibition abroad. So you see, it's a very practical reason usually behind the questions that we are asked. One of the risks depends on the presence of iron gall inks, which, as you well know, can corrode the page and eventually destroy the page itself. Didn't happen with Leonardo Codices, I swear. And we also wanted to characterize the sanguigna, which is the chalky pencil or pastel that Leonardo used on, extensively on all the codices, and compare the different types of writings, because there is something that is obviously written by him, even if it's done with different inks, but there are other handwritten notes that we suspect they are not his and were added at some point during the codices histories. And then we would be able to discuss with curators, conservators, to decide if any treatment is needed, to provide guidance on handling and display, and make comparisons with other notebooks and manuscripts elsewhere. This is our non-invasive analytical protocol, which included infrared reflectography to observe differences in the writing materials absorption in the infrared, high-resolution digital microscopy to highlight details, scanning XRF to define the distribution of elements on the pages, and finally Raman microscopy to confirm the molecular composition of the writing materials. And one of the things that we were able to confirm indirectly is that Leonardo often took notes using sanguigna while on the move, and then only the notes worth keeping would be retraced with ink once Leonardo was back at his desk. And you can see this in the photo on the right-hand side, because there is an imperfect overlapping between the sanguigna and the ink. Excuse me. The analysis by Raman microscopy of this page confirmed that hematite is the main component of the sanguigna, and iron gall ink is the main component of the ink. If we look at the XRF analysis, the XRF mapping, it did give us a clear visual indication of this, because the iron map matches both the sanguigna. Thank you. Both the sanguigna and the inks, and visually there is the added complication of the fact that the XRF map shows everything that is present on both sides of the page. So you see the map of iron that comes from both the verso and the recto of the page, which, if you want to get a nice clean image, makes life a bit difficult. And then, as I mentioned earlier, there were different types of inks on the codices, and it would be very tempting to try and identify them by eye and say, oh, the black ones are carbon-based ones and the brown ones are iron gold inks. Obviously, we know better than that, and in this case, we had to test them all, and they are all mixtures containing iron gold links, with the exception of the one on the top right of the screen, the yellower ink, for which I was only able to identify the impurities. So by Raman, I could identify carbon black, hematite, and orpiment. And just by the look of the inks under the microscope, I could tell that there was probably a very diluted version of iron gold ink and an hydrated iron oxide of an amorphous type. But obviously, I couldn't get a Raman spectrum, so it is still all based on experience and expertise and good old guesswork. On some of the pages, the infrared reflectography experiments revealed something unexpected. As a general rule, carbon blacks remain visible in the infrared. Iron gold becomes transparent in the infrared. Occasionally, we have something in between, which probably indicates that iron gold link was mixed with other things that makes it still visible in the infrared. And there is an intriguing piece of evidence. If you look at the bottom right of the infrared image on this slide, you can see that the iron gold link is a lot more visible on the right of the paragraph than it is to the left. And remember that Leonardo was writing with his left hand, right to left. So to read it, we have to use mirrors now. And obviously, when he put his nib on the ink and then started writing, there was something in the rheology of the ink that allowed the infrared visible elements to be retained at the beginning and then not to be present anymore at the end of the line. And again, it just gives you an inkling about the way he used to actually physically write things. This is ongoing work, so we are not drawing any conclusions. There are still experiments to be done, but I thought it would be something that you haven't seen anywhere else because it hasn't been published yet. So to sum it all up for the first case, so for the Leonardo codices, what we are doing is allowing to shed light on the history of the codices, for example, the way they may have been put together. They help in their authentication, for example, by identifying original materials, later additions, but also past conservation treatments, and to address conservation concerns, specifically identify the risk of lending the manuscripts for an exhibition, monitoring the degree of degradation of iron gold links, and advise on the sensitivity of materials. And this is my second example, which many of you are probably already aware of, at least the beginning of it. This study relates to indigenous American lacquer, which is something that I started working on relatively recently, but is really a gift that keeps on giving. What is it? There are different types. The most famous one is probably Barniz de Pasto, which is obtained from the buds of a plant that grows mostly in the Andes in South America. But there is also Mexican lacquer, which is made of chia oil combined with an insect fat known as aje. And then many, many other types of regional lacquers that are from all different regions in Latin America. What is common in all these objects is the glossy and durable finish they all exhibit, and you have a few examples here. Some of you may have already heard of this. This table cabinet came into the V&A in 2015 and was routinely analyzed just as any high-profile object that enters the collections. And the first discovery was that the white pigment used ubiquitously here was calomel, which I promptly rechristened mercury white because it was the very first documented occurrence of it as an artist pigment. So we have lead white, we have calcium-based whites, and I christened it mercury white. And the first surprise came, the second surprise came when we x-rayed the cabinet. You can see here the lid, what you see with your own eyes, and this is the X-radiography, which has nothing to do with what your eyes see. There is a skeleton in the center. And so we used micro-CT at the Natural History Museum first, and then mapping XRF at the National Gallery, who generously gave us access to the equipment before we bought our own. Yay. And this map shows all the areas on the lids where mercury is present, outlining what must have been the bulk of the original decorative scheme made with mercury white. And with other analysis that I did, I could confirm that what we see is a 20th century repaint, and after some sleuthing, I confirmed that the pigments must have been applied after 1958, so it's something quite recent. To cut a long story short, 8 years after discovering the presence of the hidden skeleton, it was just 2 weeks ago that my colleague Dana Melker started removing the late 20th century paint to reveal what was the original scheme. And you can see here on the left, and to my great delight, I was actually allowed to remove some of the paint myself, so I donned the lab coat and was allowed to be a conservator for a few seconds under Dana's guidance. And it was really something very nice from a personal perspective. And what you can see is that the removal of the 20th century overpaint reveals so many additional details and colors we had not expected at all, because they are all organic, so they don't show up in the X-ray maps, the XRF maps. And there is a variety of pinks and mauves which cannot be seen anywhere on the cabinet because they have actually faded. So that brings a lot of implicit issues about how do we exhibit this, how do we display, how do we make sure that what has remained untouched continues to remain untouched. Going back to American lacquer in general, because I'm aware that I'm running out of time. As a result of our research, we developed an international network and fostered new knowledge exchanges about these objects. We overcame both geographical and language barriers because we organized our first international bilingual gathering dedicated solely to indigenous American coatings. Speakers came from all over the world, and we had so many different people gathered together with so many different backgrounds. We had scientists, conservators, curators, and art historians, which is normal in a museum setting, but we also have social anthropologists and designers and makers and jewelers and so on. So this is, instead of having a magic triangle, we have a magic octagon. And as a result, we are all now looking for items that are made of indigenous American lacquer in our collections, but we have not recognized as such so far, and we have helped to identify one at the British Museum and one at the National Trust. And this is my last slide. You will be very happy to know. I know, but I get anxious. So what to take away from this is that, I know to you this is all very boring and very obvious, but to people who are not in a museum setting, this may not necessarily be obvious. The border between routine collection care and research is more porous than expected. And you really need to continue to be curious and open-minded in order to keep that fresh outlook on heritage science. And the magic triangle or polygon really works when you really put some effort in it. And just by looking at the program for today, so it doesn't have anything to do with the V&A or with my work there, the fact that there are so many of us doing this work is a testament to the quality of Italian education. And I'm talking from primary school onwards, not only just university, in the 70s, the 80s, and the 90s, and in the case of some of the speakers today, even the noughties, the 2000s. So well done, Italy, because you have spawned a lot of us, and we are kind of secretly and silently invading the world. And a few acknowledgements, Dana and Valentina at the V&A for their work on the Barniz de Pasto and Leonardo respectively, Marta, who spoke earlier, and David Peggy at the National Gallery, because one of the maps that I showed today was actually taken by them. And I did mention them before, but I didn't show any of those results. The Natural History Museum, of course, because they helped us with the micro-CT of our cabinet. And all of you for your attention.
Thank you, Lucia, for your comment on Italian education. Also, you used a few times the word amusement, joy to work. And I can give my personal experience, how it is important to work seriously with enjoyment. I am now involved in a very crazy project, crazy from my age. We are giving to 9 Italian contemporary artists Egyptian blue to make their artistic procedure with these new materials. And we are planning 24 exhibitions in the next 3 years, 12 in Italy, the other all over the world, States, Egypt, China, and so on. So I was trying to find a sponsorship, and I had an important meeting with any top-level management. When they asked me, why are you enterprising this venture, this project, I say, because we want to work with amusement and joy. And that was the working word. They appreciate very much the fact that we working with amusement and very seriously. And they gave the sponsorship. So it's very important to have this attitude towards our job. Thank you again, Lucia.
Thank you.
Now we pass to two remote presentations. Until now, the remote presentation was very, very good indeed. I must say that I am a little contrary to remote presentations, but I am astonished how it's working in this. And my compliments to the technicians that are doing such a good job. Now, Eleonora Pellizzi, Gianluca Pastorelli from the Copenhagen State Museum for Kunst will have the microphone. Gianluca, it's your time to talk.
Yes, thank you very much, Professor. I hope you can all hear me.
Yes, very well.
Perfect. And,
unfortunately.
I will try to share my presentation and hopefully also put it full screen. All right. So today I'm going to talk about a bit how artificial intelligence and specifically machine learning are revolutionizing the field of heritage science. And I will focus on a few case studies related to the Danish painter Willem Hanassai. And I will structure my presentation in 3 sections. I will talk a little bit about my personal background. I will show then the case studies I just mentioned, and I will conclude with a few comments about the future of heritage science. So, regarding my personal background, I am currently a senior heritage scientist at the National Gallery of Denmark, or SMK. But my path, the path to get to this position has been extremely convoluted. I would say that it's not a textbook example, but everything started with a master's degree in natural sciences, specializing in natural conservation, so a very different type of conservation. But this gave me a general scientific knowledge that I could apply on my first job as an environmental chemist at a local environmental agency. I was basically the guy who makes sure that the water coming out of your kitchen tap is drinkable. But then I wondered whether the analytical equipment that I was doing for that job could also be applied in other contexts, such as the study of cultural heritage. And this led me to pursue a postgraduate degree in archaeology and archaeometry, where I could indeed apply those scientific methods to the study of cultural heritage. And after that, I worked for a while as a geoarchaeologist, where I finally had real contact with ancient artifacts, and especially with a material that I find most fascinating on Earth, which is amber. I could work on archaeological artifacts made of amber. And just because people often ask me this question, I'm going to answer it right away. No, I never managed to extract dinosaur DNA from amber, but I could see that a material like that is very prone to degradation. So this created some interest in me regarding the topic of conservation of cultural heritage. And this made me pursue a PhD in conservation science. I was enrolled at the University of Bologna, but I carried out most of my work in Denmark. And finally, I could become a heritage scientist, and I had the opportunity to work in different prestigious institutions around the world, including universities and museums, and focusing my research on characterization of artists' materials. And I guess Francesca can probably recognize in the bottom corner one of the artworks we worked together some years ago. But that's enough about me. Let's talk about Willem Hammershøi. Hammershøi is a Danish painter who was active between the end of the 19th century and the beginning of the 20th century. And there is an international interest that is growing in this artist. At the same time, his painting techniques and material choices are relatively unexplored. So that's why we created this project, the Willem Hammershøi Digital Archive, which aims at shedding light on his working methods, and including the use of very specific pigments. In this project, we result in an open access online archive, which will hopefully advance art historical research and authenticity assessment, and also conservation of artworks by Hammershøi through all the technical data that we are producing. And talking about applications of machine learning to the study of artworks by Hammershøi, this is actually an example, and this work has been published recently on X-ray spectrometry. We worked on this portrait. It's a portrait of another artist, incidentally, Jens Ferdinand Willumsen, but it was made by Hammershøi. And we work a lot with X-ray spectroscopy, mostly macro XRF. And the usual way to work with this technique is to produce these single element distribution maps and to find correlations between the different elements in order to identify pigments. But we tried a different approach. We used a machine learning technique based on neural network that is called the self-organizing maps, which can produce, among other types of plots, these heat maps that are related to single elements, but allow us to look at the presence of these elements in a different way. For example, we can see very clearly the similarity between the maps of phosphorus and calcium, suggesting the use of bone black in the paint layer of this painting. But also, if you work with XRF, you know how challenging it is to distinguish the signals from barium and titanium. Well, these heat maps actually can show that the signal from barium is actually extremely noisy, while the one from titanium is very localized, indicating the use of titanium white for retouching. And again, the correlation between cobalt and nickel, that it is suggested by the maps, the XRF maps, actually this correlation is absent in these heat maps. And we can see that only cobalt is actually present, while nickel is, the presence of nickel is basically an artifact. We can then try to use further techniques such as hierarchical cluster analysis to create groups of elements that are related to specific materials used in the paint layer, and we can plot these clusters, and we can also separate them and inspect their individual elemental compositions. And I don't have the time to go to the details, but it's interesting to see in cluster 7, for example, which is very rich in cobalt, and this cluster is associated exclusively with the eyes of the figure in the portrait. We try to use these techniques also not only with XRF, but also with SEM EDX analysis. We collect samples from the tucking edges of all the Hammershøi paintings that come to our laboratory. And we tried to explore the composition of all these samples in order to identify the types of ground materials that were used by Hammershøi. And this is what we obtained. We could identify 5 main types of ground layers, and we could plot them versus the year of production of the paintings that we analyzed. And we can see that most of the paintings have been produced with ground layers composed of mostly lead white or a combination of lead white and calcium carbonate. But there are a few outliers, such as these 2 paintings, mostly composed, which have a ground layer mostly composed of calcium carbonate. And these paintings were produced by Hammershøi when he wasn't in Denmark. The portrait was produced when he was in France, and the church interior when he was in Italy. So during those times, he was exposed to different materials, and these drove a little bit his choices. And then there is this unique painting that was that contains a ground made of an iron-based earth. And the time when he produced this painting, he was still a student. So it's something very different because it's not really an expression of his art, but it was basically a school assignment. Changing topic, we don't work, of course, only with XRF, we work with other techniques, everything ranging from UV reflectance spectroscopy to visible spectroscopy, near-infrared and mid-infrared spectroscopy. And very often when we acquire spectra using these techniques, these spectra are mixed. They contain reflectance bands that originate from multiple materials present in the artworks. So the problem is to identify the components that make up these mixed spectra and try to quantify their contribution to the acquired spectra. And the steps for what we call spectral mixing are basically 2. First, we need to identify the reference spectra, or enmenders, as they are known in the field of hyperspectral imaging, that contribute to the mixture, and to compute the mixing fraction for each enmender. Now, I really don't have the time to describe all the techniques that have been successfully used for this task, but we focused on one technique that is very useful for single point measurements, so not hyperspectral imaging, but single measurement. And this technique is non-negative least squares. Based on this technique, we developed a workflow, which was presented recently at the IRAG 15 conference in Tokyo, Japan. And again, I don't have the time to go into the nuts and bolts of this method that we developed, but there are different steps, such as the concatenation of different spectra that are acquired with different techniques in order to create these broad spectra that contain all the information that we might need, and then the unmixing process based on non-negative least square, and the identification of those components using an ensemble of supervised machine learning techniques. We originally developed this technique for identifying cobalt pigments, but now we use it for all the different pigments that we have included in our database. And some algorithms work better than others, but in general, we can reach a fairly good accuracy. We don't use this technique very often for Hamasoy because he used mostly inorganic pigments, and we make extensive use of XRF. But we try to play a little bit with it, and specifically on this example, where the foliage, the green foliage in this landscape was produced actually with a mixture of cadmium yellow and cobalt blue, and this was confirmed indeed by XRF spectroscopy. To conclude, because I see that time is running out, we also try to work a little bit on the correlation between crack morphology and ground materials. Especially, we did this working on another Danish painter who is Jens Juul, and this is an unpublished work. But we try to classify the cracks that are the crack patterns that are developing on the surface of many paintings by this artist. And using principal component analysis, we could group these crack patterns into 4 distinct categories. We also used the SOM-HSA method that I described previously to classify the different ground layer materials, and we could identify 4 different types of ground materials. And we tried to see if there is a correlation between those 4 crack patterns categories and these 4 ground layer types. It's not perfect, but there is a fairly good correlation. So the goal is to develop an image classification algorithm based on supervised machine learning and convolutional neural network in order to automatically classify crack patterns on the surface of the painting and therefore infer the composition of the ground layer. When we came across this painting by Hamasoy that developed these cracks on its surface, and this is a pattern that the conservators call alligatoring, which I find amusing, but also very spot on. We tried to see if there was a correlation, according to the model that we developed for Jens Juul, between the ground material and this specific crack pattern. We can see that the ground is mostly composed of lead white, and according to that model, there is no match. So we assumed that there is another material in the paint layer that is actually creating these cracks. And we sampled, we collected 3 samples. It's something that we don't do very often, but we collected samples from the paint layer and we analyzed them with ATR, FTIR, and we could indeed identify asphalt or bitumen, which is a hydrocarbon-based pigment that indeed on the long term is prone to the production of these specific crack patterns on the surface of the paintings. So to conclude, what is the future of heritage science based on what I presented? Why artificial intelligence-driven methods are important? Well, for different reasons. Scientific methods are becoming more and more efficient. They can collect a very large volume of data very quickly. So it's necessary to use advanced data mining techniques to find meaningful patterns and trends in that extensive data. And also sometimes researchers don't have the opportunity to use multiple complementary techniques to identify materials accurately, especially when these materials are mixed. So it's important to develop methods, the mixing methods that can work with limited data and they can improve the characterization of materials. And also, very often it's challenging to decide whether or not to collect samples. So to have advanced models that can predict certain type of results can help researchers in making better decisions regarding the collection of samples. So I want to thank you for your attention, and especially I could thank 100 people, but I really would like to thank specifically some of the forward-thinking people who have helped me to shape my career, and I am very grateful to them. And again, thank you all for your attention.
Any comments, questions? No? We thanks again Gianluca, and we pass to the next speaker, Eleonora Pellici. In the program was a remote participation, but with great joy, now she appears in presence. From Parigi to Rome, the microphone is to Eleonora.
Thank you so much, Antonio. Yes, actually, the BNF proposed me to come, so I couldn't say no.
Yeah. Always Rome deserves a mess, like Paris.
Yes. Thank you so much, and thank you to the organization for inviting me. I'm Eleonora Pellici, and I'm working at the BNF, so at the National Library of France. And I want to share with you today recent study on the conservation of rubbers in contemporary and modern art collection. But before that, so few words on my backgrounds. I studied at University of Turin, so I had a bachelor and a master degrees from the University of Turin that allowed me to have a really good background on materials and their degradation. And here you have just two examples of work of arts that I work on. So a manuscript and a funeral mask of the Egyptian Museum. And as been already told today, I'm really grateful to the Italian education for giving me a very solid scientific background and to a very early class in the university with art historians as well and restorers. After my degree, I went to Paris and I started working at the Research Center for Conservation that is in the Natural Museum of Paris, where I worked really with problems and issues coming from conservators' problems. First on the Haringel-Hinks issues, and then I made my PhD on the conservation of polyurethane foams that was founded by a European project that was called POPART. And so there I really started to work on issues really related on conservation problems. And then after my PhD, I had the opportunity to have a postdoctoral fellowship in the Center of Atomic Energy in France, where I studied the degradation of synthetic materials, so of plastics, under ionizing radiations. So I really learned a lot about the analytical techniques. So I really thanks the Atomic Energy Center. And what I learned as well was the importance to really share in a very clear way with the with all the people that are working on a project, and just to make the exchanges as clear as possible. But then I really missed the cultural heritage field, and I had the great opportunity to join the BNF in 2016. And there, it was really a good opportunity for me, because at the National Library, I really can combine all the experience that I had before on the writing materials, on manuscripts, and also on all the experience that I had on synthetic materials. And here I put a very good example of that, because this is a printed book that is conserved on a polystyrene coffin that that had a box of cellulose acetate. So it combines really a lot of different problems in one. And here you can see again the three field scheme with scientists, curators, and conservators. So all the experience that I had really lead to me to learn how to work well in between scientists, curator, and conservators. And what helped me as well was to work with formation center for conservators in France, so like the Institut National du Patrimoine and Beaux-Arts in Tours. So there I work really in the formation for conservators. What is really nice in the BNF is that you have scientists, curators, and conservators working together in the same institution. And so this is a real advantages for conservation science. And what I think as well is that, at least at the BNF, the scientific research had to really answer to conservation and curator problems. So this is the reason why I will talk and share with you this project about rubber, where we started to really collaborate with conservator working at the Centre Pompidou. So how this project started, we realized that we have very similar problems in the collections. So you can see here on the left and on the right 2 works of art of the Centre Pompidou. So the plus and minus box of Robert Morris and the plinths from Richard Serra. And at the BNF, so at the Centre Pompidou, you have a lot of obviously modern and contemporary materials and a lot of rubbers of many different kinds. And on the BNF, we have a very big collection of technical devices that are conserved to reproduce audio and video supports. And in this historical collection, you have a lot of rubbers. So we found it to have very similar problem of conservation. And here you can see 3 images of the typical degradation that you can have on rubbers materials. So we decided to work together, but at the beginning we have to define clearly what were the objective of this collaboration. So what we wanted to do, first of all, we had to be able to identify clearly the nature of the rubbers in the collection, and we realized that we were not able to do that. And why we wanted to identify the nature of the rubbers was to better understand the degradation that we observe in the collection, and at the end with the aim to develop conservation treatments. So we started with the first question, so how we can identify clearly these materials, and we looked for foundings because it was absolutely necessary to perform this research. So we had found this from a foundation, French foundation, that is the Fondation des Sciences du Patrimoine, from the French Ministry of Culture, and as well for a foundation of the Michelin company that helped us so much in this project, because they really have a lot of knowledge, obviously, about rubbers. So what rubbers are? Actually, rubbers in the pre-Columbian Mesoamerican civilization, they already know really well how to produce an elastic materials from the latex that you can get out of EVA trees. But in the modern time, it was from 1839 that in Europe it was rediscovered the vulcanization of the rubbers by Mr. Goodyear. And at the beginning of the 20th century, we have different kind of new family of rubbers that appears that were now synthetic materials. So you start to have natural rubbers and then polyisoprene synthetic rubbers with a lot of other families of rubbers like the APGM, SBR, NBR, etc. And what is important to know is that when you have a synthetic material like an elastomer, you always have a polymer and a lot of additives. So this complexified quite a lot the identification. We also decide to work with other scientific laboratories. So we work with the CRCP in Marseille and the C2RMF in Paris joined the project as well. And they work with us on the scientific part of the project that is called ESPION, so it's elastomers identification by pyrolysis GCMS in museum collection. And the idea was really to develop an analytical methodology in these laboratories so that we can share the data and we can reproduce the methodology on the 3 labs. And we wanted to test this methodology on the collection of the Centre Pompidou. So what we started with the constitution of a reference database. So we collect a lot of reference materials, so partially from the Michelin company and from chemical suppliers as well. And we analyze all these different elastomers to create a reference database. And we use a multi-step process with the pyrolysis GCMS. So what we have done, we take the sample and we heat it at 200 degrees. So we can analyze only the additives of the samples. This is what you can see here in the pink chromatograms. And then the same sample, we heat it at 600 degrees to really have the signature of the polymers. And we have done that with all the reference that we had. And then the idea was to do exactly the same on the samples from the works of art. So what kind of data we have? We had, here you can see two kinds of chromatograms of two reference. So on the upper part you have the styrene butadiene rubber, and on the lower part you have the butadiene rubber. And what we had, the information that we can have were to see some characteristic markers of families of polymers that are so common to different kind of elastomers. And then for some specific case, we have really discriminant markers of one kind of elastomers. And we collect all this information on a database to help us in the identification. So I just show you very rapidly how this works. So this is an example on one of the sample of work of art from Gilles Touillard. This is the interface of the database, and in this part you can import the data, the raw data that are constituted by the 10 major ion of the mass spectra up to 25 major peak on the chromatogram. And when you put your raw data in the interface, you can have an immediate result with the best comparison with all the elastomer of the database that we collected before. So for this special case, we had polychloroprene. So we analyzed last year 265 samples from the collection of the Centre Pompidou. And we have seen that they have a lot of natural rubbers or polyisoprene synthetic rubbers, because we realized that we cannot differentiate really the natural rubber from the synthetic rubbers. And all these data were analyzed also by the conservators of the museum to see if we can see a connection between the nature of the polymers and the degradation that we observed. And so all this data analysis is still ongoing, but we can see that a lot of the objects that have conservation problems and degradation apparent are almost natural rubber and polyisoprene. What surprised us a little bit was that even if we construct our database on new materials, so not degraded materials, we had a really few amount of sample that we were not able to identify. So this was quite good for us. And before concluding, I just spent a few words on the age of the samples. So here you have the picture of some sample identified as natural rubbers of different ages. And what we can see in the analysis, we can see that in the three recent samples have a very similar signatures, and we can clearly identify the characteristic markers for polyisoprene. And when the rubber is aged, the signatures start to change a little bit. So you can always see the characteristic markers, but you start to see also different kind of molecules that are modified terpenes that are probably due to the degradation of the isoprene dimers. And so this is a big project that we started, and it will not end in 2 years, so we will still keep going to work on it. And now what we would like to do is to have a better understanding of the degradation of these materials, especially natural rubber, and we would like to reproduce in the laboratory some samples for conservators so that they can make some restoration tests on samples that are representative of what we see in the collection. So this is the phase that it's ongoing now at the laboratory. And I just want to thank you so much, all the people that work with me in this project, and especially Caroline Bouvier that spent 2 years working on the project as a postdoctoral fellow, and that he's going to work with the Risk Museum next year. And special thanks also to Isabelle Cuoco, that he's the conservator that made all the sampling on the object of the Centre Pompidou. And thank you for listening.
Thank you, Eleonora. Your affiliation is the French National Library.
Yes.
That I know very well, because he is one of the few pre-Columbian codex, the Bourbonicus codex.
Yeah, exactly.
You know that there are 13 in Europe, all in Europe, and we have studied by Molab 9 of them. But unfortunately, not the Bourbonicus Codex, because it was studied by our good friend, Bernardo Lavedrin.
Yes.
So I visit and discuss with him. Thank you.
Thank you.
We have time for one question, one comment. Okay, thank you again, Eleonora. Now, the last speaker, but the first on my heart, Francesca Gabrielli. It sounds very strange, odd to me called Francesca, because it was Franceschina for us. I still remember when very young and shy was sitting in the first bench in Via Elce di Sotto, listening to my lecture on inorganic chemistry and to the Brunetti lecture on cultural heritage. The microphone is yours, Franceschino.
Thank you. Okay. Thank you so much, Professor, for the introduction, and all the organizers for inviting me, because it's really an honor for me to be here today. So I will talk a little bit about what I've been doing at the Rijksmuseum in the last 3-4 years, and I will actually point a little bit the attention to the potential of reflectance imaging spectroscopy in a museum environment. But before to do that, I would like to recap a little bit my history. As Professor Scamerotti just said, I graduated in chemistry and physical chemistry at the University of Perugia, and I had the chance to meet Professor Brunetti and Scamerotti, which really communicated all the love and passion for this field, and I actually started my journey with them and Costanza and Francesca Rossi and all beautiful people in Perugia. And I did my PhD there and worked with them for about 6 years, doing a lot of different MOLABs around Europe. I had a chance to analyze many artworks from archaeological sites to Jackson Pollock, as you can see in the picture. And I learned a lot about hardcore spectroscopy, I would say. So really the basic spectroscopy things, but also a lot about the approach, how to approach the analytical study of an object, an art object. And I had my first interaction with conservators, because all the users, MOLAB users, were conservators that were asking a very specific question that we had to answer. So that was a very formative experience. But sadly, after my PhD, I had to move because not a lot of possibilities were opening. And I basically moved to the United States for my postdoctoral fellowship at the National Gallery of Art in Washington, D.C., where I had the privilege of working for 3 years with John Delaney and Catherine Julie. And I have to say that I feel very lucky because I learned a lot about spectral imaging, in particular reflectance imaging spectroscopy, and it was very formative for me. And at the same time, I really could interact more with conservators and curators on a daily basis, trying to understand what were their questions and also their requirements in the analysis of artworks. Then, after Washington, I was lucky to land in Amsterdam at the Rijksmuseum, where I am now part of the team, the scientific team led by Katrien Keune. And in Amsterdam, I basically replicated the system that John has at the National Gallery, so I am now responsible for the reflectance imaging lab and everything that has to do with the reflectance spectroscopy. And I was part of many projects, and I will show today a couple of them, which I think are very important, not just for us as a scientist, but for the museum, for curators and conservators. I just wanted to really recap briefly what is reflectance imaging spectroscopy. We have heard today from Marta and also from Gianluca about this technique. I don't know if the audience is all familiar with it, but to understand a little better what I'm going to tell you later, I think it's good to just have a quick recap. So we are working in a spectral range that goes from the visible to the near IR and deep to the short wavelength IR, where we can actually have information about electronic transition and vibrations of molecules. So we are looking at molecules, so molecular information. And this is a very complementary technique to other, like X-ray fluorescence that gives elementary information and so on. And what we do is very easy, let's say. We shine some light, not too much, to the painting, and we collect the light that is reflected from the materials with imaging spectrometers. One thing that I want to point out is that different wavelengths have a different penetration depth. So when you work in the visible range, you're going to be very sensitive to the surface, so to the materials that are on the surface. We talk about 10 to 50 micron, depending on the materials. When you go into the near IR or short wavelength IR, you're penetrating down to the ground. And that's a very, very important information for what is coming next. What do we do with this scanning, with this reflectance imaging spectroscopy output? We actually collect something that we call a 3D data cube. So we have as X and Y the coordinates of our painting, and the third dimension in this case is the wavelength, but in the case of the X-ray fluorescence, it's going to be the energy. What do we do with this? We can do mainly two things. One is creating what we call false color images. How do we do this? We slide this cube, and we basically obtain an image per wavelength. And I'm showing you some examples of some of the wavelengths. And then we can basically combine some of those images to create false colors. We know that a normal visible image is made of 3 channels, red, green, and blue. And we can actually pick any of the wavelength image and substitute these 3 into the red and green and blue channel. And what we are going to have is an image that looks like it has colors because materials are responding in a different way to light, so they will appear in a different color. I will explain a little bit better in a second. Another thing that we can do is chemical mapping. We can basically identify one of the some reference spectra that we call end member. And once we know that that spectra is related to a certain molecule or a mixture, we can decide to map those spectra on the surface of the painting through algorithm like the spectral angle mapper. I'm not going to go into detail, but you're always welcome to ask. And I've been basically scanning a lot of painting in these years, but I was very lucky this year because Rijksmuseum hosted an extraordinary exhibition of Johannes Vermeer, who is a Dutch master active in the 17th century, and we were lucky to have on our walls 28 over 37 paintings by Vermeer. And during the exhibition, before and after actually, we had a chance to analyze 12 of these 27 paintings with many, many different analytical tools, imaging and not, and in collaboration with the Mauritshuis and the University of Antwerp. And here are my colleagues. And something that I really I wanted to say before, but I will say now, is that what I found very important at the Rijksmuseum in particular is the collaboration with the conservator. We work together every day, and we look at the painting together, we look at the data together, and whatever I'm showing you today is really the results of a very close collaboration. So this is our masterpiece, The Milkmaid by Vermeer. We, as I said, analyzed with many, many different techniques. And the results, of course, of all the identification of materials and pigments is a puzzle that we have to put together. And reflectance imaging spectroscopy, in particular in the visible range, is really allowing us to map some of those pigments that are mainly in the palette of Vermeer, such as ultramarine blue. Ultramarine blue is not really straightforward to be identified with X-ray fluorescence, for example. So reflectance imaging spectroscopy in this case is very powerful. And ultramarine blue is basically the most used blue by Vermeer, and was a very, very expensive pigment. So it was interesting to see how he was using it. And as you see here in this image, we are mapping the presence of a very blue, pure blue, on the apron of the milkmaid and on the tablecloth. But we can also map the presence of an ultramarine that is mixed with a yellow to achieve a green tone on the tablecloth, for example, or on the sleeve of the milkmaid. And I want to point the attention onto the flesh tone, because Vermeer used ultramarine even on the flesh tone to achieve a shadow, basically, which then will actually change in his career. And we discovered that in later paintings he will change this green tone with a green earth, so actually with a green pigment. But in this case and other paintings, he was using ultramarine mixed with a yellow ochre. And this was a nice the mapping of this kind of pigments. It is important because indeed you can not only identify it, but also see where he's actually using it, so as to understand the technique. Then once we have scanned the painting with the vignette, so with the visible, we have identified a lot of different pigments. It is important to go look at what is underneath of the surface, and we can do this with the SWIR because we are indeed penetrating deep to the ground. And what we end up with is an image like this. As I said before, this is a false color image in the SWIR, and it's like you are peeling off the layers of the painting on the surface that are transparent to the IR. For example, on the apron, the ultramarine is, of course, transparent to the IR. So what we are seeing, here is the underpaint, and you are seeing here something that looks like very dark, because there must be a pigment underneath that is absorbing the infrared light, resulting in a dark in the image. And we know from X-ray fluorescence that there are not a lot of heavy elements there, so we assume that that's a charcoal black. And this means that he basically built up the painting in the underpaint using a dark underpaint. And you can notice the very coarse brush strokes that are running under the arm and on the sleeve. And he was already defining the dark and the light in the underpaint, which is that's the information that we achieved about his creative process. This was also confirmed spectrally, because as you can see, if you compare two spectra that are coming from the apron, one having the dark underpaint and one without the dark underpaint, you can see how spectrally those two points are different. He does the same thing on the tablecloth. He defines the shadow in the underpaint with a dark paint, which is opposite to what he does in the lighter areas. And this is confirmed with the X-ray fluorescence mapping, where you can see the presence of a LED in the light areas, while there is less LED in the dark areas. And also, it's very interesting, as I said, to always go back to your painting and look at the painting, because what you see with the microscope is actually that under the light, the light blue, there is a white underpaint, while under the darker tablecloth, there is a dark underpaint. You can see it clearly through the cracks. So our scientific investigation was actually confirmed looking at the painting. Important also with the reflectance imaging spectroscopy in the shortwave and IR is to be able to look at changes when they are present. And what we could actually see behind the face of the milkmaid is the presence of an element, a couple of elements. And of course, this was also seen previously in a normal IR reflectography, but the lower spatial resolution didn't allow to really understand what it was. But then, thanks to, again, the collaboration with curators and conservators, we have a theory that this is a jug holder, which actually was present in a dollhouse of the same time, and also in other paintings. So that's the theory that we have. I don't have a pointer, but you can see actually the shape of the jug holder on the right of the milkmaid. And another change that we noticed is on the right of the figure, there is in the visible image something very weird, and when you look at the Zweer false color, you can see that there is a shape, and this is the shape of a basket, of a fire basket, where then there was a little fire inside, and then the laundry was supposed to hang to dry. So we believe that this black blob that you see was actually sketched for the laundry, and then you can clearly see the line, the shape of the basket from the false color. And it is very powerful to have an image like that, because of course you see the two materials reacting differently. You can better separate the two contributions. And this was also confirmed with the matrix ray fluorescence, where we could actually map the tin. So we know that he sketched that fire basket with probably Latin yellow. Okay, so going from Vermeer to Rembrandt, because I was involved also in another project, a big project that Francesca mentioned this morning. I wanted to show you this parallel, because Vermeer paints very small paintings, while Rembrandt paints very big canvases. So it's challenging for us as a scientist in a museum to be able to provide the same kind of information for such a small painting and in a big painting. So we started a journey in 2019 called Operation Nightwatch. We built a glass house in the museum. You can see here the Nightwatch, and the dimension is a pretty big painting. We spent 2 years researching this painting with many, many different techniques, and these are the photos of all my colleagues involved. And this research was actually done to provide an information on the condition of the painting to help the conservators in understanding whether it was necessary to treat the painting or not. And now I can tell you that yes, the answer is that the painting will be treated, and we are now in the phase of testing the cleaning methods. But I think it's very important to point out that this was done in front of the public, of course, but the main thing is that our research was really a way for the conservators to get to know the painting in a better way. And I want to just show you quickly, this is the imaging setup. We had an imaging frame built around the painting, and the camera was sliding in front of the paintings to acquire our 3D data cube that you saw before. And these are the two cameras that we have at the Rijksmuseum in front of the Nightwatch. On the left, the visible Tunirayar, on the right, the Zwir. And we also built a special system that was allowing us to focus during scanning, which was the first time that this was done. So not only moving the cameras X and Y, but also in a Z direction. And this is the paper that we published about that. It was a big work for me. We scanned for like 2 to 3 months in the morning, in the night, and we had to scan a lot of different areas and then stitch it together. And this is just to make you understand how big of a plan this was and how big the data set at the end we basically had to deal with, which is still actually something that we're doing. I mean, we're still looking at data. And thanks to the help of Robert Erdman, which is our data scientist, we were able to stitch all those little acquisitions that we made. And one is the visible image reconstructed by the with the Vernier camera. And on your right is the false color infrared. And he built a tool for us that we can basically navigate the painting very easily. And here I want to show you an example. I hope, yeah. This is the Zwir false color. I am zooming in basically, and you can see that it's very easy to visualize areas that are abraded because the canvas results blue in the false color. So it's very easy for the conservator to open this image and go look around where they can see the canvas and know that in that area there is an abraded area. So it's important for their conservation treatment. And this was also confirmed spectrally, of course, because we can see the canvas in the spectrum. And this was my last example. I think I'm in time. So I want to thank you all for the attention and the Vermeer team and the Operation Nightwatch team for the work that we do together.
Thank you, Franceschina. I am so happy to see a young students grow up as a brilliant researcher. Now, at the end of the first session, I want to make a comment, which is in a way trivial and sad at the same time. Sad, usually I am optimistic, but I must say that I feel a little sad to see so many scientists with their good education in Italy working in many important museums abroad, since they did not have any opportunity in Italy. It is time and necessary to invert this tendency. We shout these sentences many times, but I think it's time to do something. I consider, of course, very important to have expertise in an international context, but we need to have back in Italy at least part of these scientists that, after their experience in abroad, to preserve our culture, diffuse cultural heritage. Now I became again optimist, which is my normal attitude, due to the high quality of this talk of Italian working abroad. I say the Italian because I consider you, Marika, since you had so many contacts with the Italian scientists, you can be considered an honorary Italian scientist. Thank you. I think that it's time to close this section. Thank you.
ready to open the second session of this, this conference. And it gives me great pleasure to introduce Antonio Sgamellotti and Bruno Brunetti for many, many reasons. First of all, because already one of the themes in this conference has been sort of a reflection about a certain tradition of excellence in scientific research and cultural heritage that the Italian school has demonstrated. And we have here two of the prime examples of really the founders and nurturers of una scuderia, of a team of really excellent practitioners in the field. In addition to this, Professor Sgamellotti is here as a representative of the Accademia dei Lincei. We're here at the Accademia dei 40, so it doesn't get more prestigious in terms of scientific heritage in Italy. And so to be welcomed as a community of scientists that work on heritage in some of the temples of scientific research, I think is a great signifier of how far this area of research has come. So without further ado, I am going to leave them the podium, and then we'll come back here promptly in half an hour, so you'll know that your time's up. Yeah. Thank you.
Thank you, Francesca. This mine will be an experiment. For the first time in my life, I will speak without slide and being seated. So I don't know about the success of the experiment. This talk is a two voices one. My voices, of course, and that of my colleague and friend Bruno Brunetti. I will touch briefly three items, giving just a few flashes without being too much comprehensive. The foundation of the National Central Institute for the Restoration, ICR and OPD, development of diagnostic techniques, and innovation in restoration procedure after the Florentine flood of 1966. The foundation of ICR and OPD. In the 40s of the last century, two central institutions, l'Istituto Centrale del Restauro, ICR, e il Gabinetto Restauri, associated to the Opificio delle Pietre Dure, OPD, were established. Both institutions are dedicated to the preservation of cultural heritage with three mandates: conservation activities carried out in their own laboratories, research activities applied to preservation of works of art, and the professional education of young restorers at the Scuola di Alta Formazione. The ICR was founded in 1939 by Giulio Carlo Argan and Cesare Brandi. Brandi was the first director and is very well known for his volume Teoria del Restauro, a fundamental book in the restoration, I would say the Bible of the restorations. And it was translated into many languages. The origins of the OPD are quite old. Founded in 1588 by Fernando I of the Medici dynasty as a manufacturing specialized in working the hard stones, le pietre dure. Following the international trend, a Florentine sovrintendente, a young one, Procacci, decided in 1932 to create a conservation structure, Gabinetto dei Restauri, associated to the Opificio delle Pietre Dure. It was the first modern restoration laboratory, at least in Italy, with an important role of the scientific investigation, especially through the use of radiography. The situation that certainly contributed the most tightening the collaboration between restoration and science occurred following the disastrous flood of Florence in 1966. There was a need to respond to seriously damaged artistic heritage that could not be addressed and resolved with traditional methods and technique. The collaboration of the scientists of many Italian universities, in primis those of Florence University, and various research institutes, like those of the CNR, became one of the fundamental channels for providing innovative and effective answers. For instance, the OPD hosted inside, since a long time, a lab, CNR INO, with reflectography instrument at the state of art. More recently, OPD hosted an INFN laboratory. INFN is the Italian National Nuclear Physics, with the first movable accelerator. The acronym is MACHINE, MACHINE, which stands for Movable Accelerator for Cultural Heritage in Situ Non-Destructive Analysis. This instrument was built in collaboration with the CERN. Development of diagnostic technique. The first diagnostic tests for artworks were carried out using laboratory bench instruments based on spectroscopy, microscopy, chromatography, and more recently, biology and also proteomics, thanks to the School of Naples, founded by Gennaro Marino. By the way, the first paper on these topics report the result of a collaboration project between the Marino's group in Naples and my group in Perugia. This technique have undergone over time relevant technological improvement with great advances in sensitivity, selectivity, macro sampling, in preparation of cross-sections. Advances in optical fiber technology, miniaturization of electronic components, and developments of increasing performance of detectors allowed for transformation of benchtop instruments into lighted portable device. The scientific Italian community gave a great contribution to the development of such portable instrumentations. Sebastiano Sciuti was the first in Italy to develop atomic and nuclear methodology to non-destructive analysis of artworks. He was one of the first to build the portable XRF instrumentation. He was in nuclear physics, and already as a student, he was very, very brilliant. Ettore Majorana, his professor of mathematics in Naples, says in a letter to his friend Gentile Junior, the son of the ministry Giovanni Gentile, Sebastiano Sciuti is one of the most brilliant students in my physical class I have in Naples. We have having some campaign with Sebastiano, and he was very proud of this statement by Majorana. Sciuti was the founder of the archaeometry in Italy, and he diffused the new science in some international conferences held at the Accademia dei Lincei. In 1972, application of nuclear methods in the field of works of art. In 2001, archaeometry in Europe in the third millennium. Some other Italian scientists gave relevant contribution to the development of XRF, both in point and image modality. Among the other, Seccaroni in Roma, Cesareo in Sassari, Pappalardo e Romano in Catania, Longoni in Milano. Portable spectrometer equipped with optics in the near-infrared region, the FORCE, fiber optic reflection spectroscopy, has been implemented and extensively used in the laboratory of CNR IFAC by Mauro Bacci and Marcello Piccolo. Mid-FTIR portable instruments were developed in the CNR ISTM and Smart Center in Perugia. The multi-near scanner device developed by the CNR INO group of Luca Pezzati is a revolutionary in the field of infrared reflectography. The first published experiment in the hyperspectral modality in the middle infrared was carried out at the Perugia lab on a painting by Alberto Burri, while tests in the near infrared were conducted on ancient manuscripts in the laboratories of the National Gallery of Washington. Innovation in restoration procedure at the after the Florentine flood of 1966. Relevant studies at the OPD by Mauro Matteini, head of the science lab, were successful in the use of ammonium oxalate for the conservation of lime artifacts and of sodium oxalate for the inhibition of corrosion in outdoor bronze artworks and archaeological objects. Very effective were the procedure applied by Enzo Ferroni, professor of physical chemistry and director of the University of Florence. Those procedures were based on the use of inorganic materials, ammonium carbonate and barium hydroxide in aqueous solution. Starting from this work, new methods were developed at the Florence Chemistry Department and at the Center CSG, Center for Colloid and Surface Sciences, under the coordination of Piero Baglioni. These methods are based on the use of innovative microemulsions and specific chemical gels. New laser application achieved effective and selective removal of andesite materials layer on stone and metal sculpture. These studies were carried out at the CNR IFAC by Renzo Salimbeni and Salvatore Siano through the optimization of laser ablation processes using neodymium YAG lasers. Before passing the microphone to Bruno, I want to present a recent initiative of the Accademia dei Lincei, the foundation in 2021 of the Centro Linceo di Ricerca sui Beni Culturali Villa Farnesina. The acronym is CERIF, and I am the director of this center. The mission of the center is to carry on research on cultural heritage with specific studies on diagnostic and resilience of the artistic testimonies of Villa Farnesina in similar size. The CERIF has established a network of collaboration with qualified public and private entities. For instance, the main research institution in Italy, CNR, ENEA, INGV, with the main museum in Roma, Museo Nazionale Romano, Parco Archeologico del Colosseo, with the Brucker Azienda and with the Metropolitan Scientific Department. Now, Bruno, the microphone is yours.
Thanks, Antonio. While Antonio has given a general overview of what has been the most relevant passages of the Italian research for the study and conservation of cultural heritage, I will move to the European context, and I will say something concerning the launch and development of a series of European projects in the field of research infrastructure that occupied practically the last 2 decades, because everything started in 2001 with the project LabStack. This series of projects have had an important role for heritage science in Europe, at least to my opinion, because they contributed to give an enhanced visibility to heritage science within the European research area. Then they gave a boost to the European research potential in heritage science, because for the first time have been open a specific program of access for heritage scientists in order to allow them to carry out their research projects, exploiting advanced competencies and instrumentation. And third, most important, this series of projects will lead next year to the implementation of the permanent European research infrastructure on heritage science that will find its location in Firenze, in the ex Manifattura Tabacchi, of which you can see there a picture, a photo picture. All these projects have been coordinated by Italy. The first project was coordinated by myself, a group of projects, LabStack, URTech, and Charisma. Then after the admission of IRIS, that is the name of the permanent future research infrastructure located in Firenze, within the S3 roadmap, coordinator became Luca Pezzati of the Istituto Nazionale di Ottica, and then now he took care of the preparation of the field for the final implementation that is now carried out by Vania Virgili, belonging to the recently created Institute for Heritage Science, l'Istituto per la Scienza del Patrimonio, del CNR. What I will do in the course of my short presentation is just to give an historical storytelling on how it has been and why it's been possible to arrive to the establishment of IRIS, pointing towards the Italian contribution. All the story starts in 1998, I would say, with the Piano Triennale dello Sviluppo Universitario of the Ministry of University and Research of Italy. In that piano triennale, it was included a call for the creation of interdisciplinary center of excellences in the Italian universities. Interdisciplinary. So through this call, it has been possible in Perugia to create a center of excellence whose acronym SMART stands for Scientific Methodologies Applied to Archaeology and Art. That was a center for research and higher education that included 5 departments of the university: chemistry, physics, engineering, art history, archaeology, together with some laboratories of Consorzio Interuniversitario di Scienza e Tecnologia dei Materiali, some laboratories of the CNR, of the Consiglio Nazionale delle Ricerche. The first president of this center was Mario Torelli, a well-known archaeologist, that then after his dismission in 2006, Antonio became president. The mission of this interdisciplinary center of excellence was obviously to promote the cooperation between humanities and physical sciences. But I call immediately your attention on the fact, I have written there in yellow the things, that one of the relevant point of the mission of the center was the development of new methodologies and portable instrumentation for non-invasive in situ measurement. And this was from the beginning, from the birthday of SMART, the main characteristics. The fact that SMART had two types of laboratory. A laboratory composed by the various benchtop instrumentation available in the 5 departments of the universities and the various laboratories of CNR. And then another laboratory that was created at that time, consisting of a set of portable instrumentation that are listed here, that you can see what they are. X-ray fluorescent was at that time a well-established technique. FORS, the fiber optic reflector spectroscopy, had already prototypes developed by Marcello Bacci in collaboration with the Opificio delle Pietre Dure. The others were assembled for the occasion through cooperation with JASCO, that is a company producer of instrumental equipment. Okay, this was the first mobile laboratory created in heritage science. Now there are several, I would say, mobile laboratories. And the motivation to create MOLAB is evident to all of once. The real secret motivation was the fact that we were conscious, we were aware that through MOLAB we had the possibility to have in our hands a good key to establish rapidly cooperations with museums, conservation institutions, and so on. In fact, immediately we established collaboration with the superintendenza, local superintendenza in Perugia, and in this picture you can see one of our first intervention on a gonfalone in the Museo Diocesano di Gubbio that was attributed to young Raphael, and Salvatore Sciuti, mentioned by Antonio, was together with us. And later, in collaboration with the Opificio delle Pietre Dure, we were called to participate to a campaign that was carried out as a preliminary to a manutention intervention on the David of Michelangelo in the Galleria dell'Accademia. In this occasion, Costanza entered in the CNR in Perugia and became member of our group, and you can see he is on the scaffolding together with other researchers. But this is the premise. What rendered it possible to undertake the first steps towards the creation of IRIS was in the fact the passage from the second to the third millennium. In passing from the second to the third millennium, within the European research program context, the fifth framework program was operative at that time, were introduced relevant novelties, new millennium, new things, new programs, new perspectives. And so starting from the fifth framework program, research infrastructure were no more considered only large-scale facilities as it was up to that moment, but also small and medium-sized facilities, provided that they had some unicity. Intended for unicity, for example, the possession of instrumentation or methodologies that were not available in any other institution. And another point was that another innovation, that research infrastructure up to that moment were created only in the ambit of physical sciences. Instead, from the fifth framework program, not only became possible to create new research infrastructure in Europe, but they were encouraged to be created in all the various strategical fields of the European research, including social science and humanities. So within the Center Smart, there was some interest to start to undertake initiatives toward the creation of the future IRIS. And together with Mauro Matteini, that had a lot of knowledge around Europe at that time, we started to contact the Central Conservation Institute in Europe, museum, universities, research centers, and so on. And we found positive responses by some laboratories, such as the C2RMF in Paris, the National Gallery of London, of the Laboratorio Nacional de Ingeniería Civil in Portugal. But not only the institutions contacted were enthusiastic. Some of them had some criticism or perplexity, I don't know. Many of the people that contacted found that this idea to undertake a path toward a European research infrastructure in cultural heritage, or in heritage science as you want, was a quite bizarre idea. So at the end, in any case, we succeeded. We knew that C2RMF was called by some French officer in Brussels to transform their accelerator located in the basement of the Palais du Louvre, Aglaé, in a European infrastructure. We knew everything from direct first-hand information through Antonio, that was member of some commissions in Europe, in Brussels. And this is the first group that was composed to start with the activities towards IRIS. Italy is present here, you can see. The University of Perugia was the coordinator. But also Opificio delle Pietre Dure and the Istituto Centrale del Restauro, both the Conservation Institute of Italy, were present. And there was an Italian representative of the ICROM, that is an intergovernmental organization. He was Rocco Mazzeo, that dismissed from ICROM and passed to the University of Bologna and continued then as a member of the University of Bologna to cooperate within this. There was also another Italian, an honorary Italian, that was Marika Spring, as representative together with Ashok Roy for the National Gallery of London. And the Kikirpa was there, and other institutions. Also, the Getty Conservation Institute started to work with us. This network had substantially the goal to create the base for a scientific community of heritage scientists ready to accept and exploit a program of access to research infrastructures. And this, the project was successful, and within the following, it was opened the first European access program for researchers in cultural heritage that included two facilities open for access to external researchers. The so-called fixed lab that was practically consisting of the laboratory Aglaé, the large-scale facilities available within the basement of the Palais du Louvre, together with all the other instrumentation available for analysis in the field of organic and inorganic materials. And then MOLAB. The second platform was mobile, composed by the instrumentation of the MOLAB of the University of Perugia, integrated with the fluorescence imaging of the Opificio delle Pietre Dure and the infrared color scanner of the Istituto Nazionale di Ottica. Then the access was indeed successful. And in the following project, it was open another access to the archives of several institutions, Agency for Conservation of the Netherlands, including, for example, X-ray diffraction in a portable version, and so on. And passing through projects and projects, this is the current situation for the accesses open to heritage scientists within Iberian HS that will be closed in a couple of months. There is open access to the archives of 14 institutions in Europe that possess radiographies, images of paintings, objects, analytical data, the documentation reports, and also access is to samples. Large-scale facilities is coordinated by the C2RMF and include instrumentation given and offered by 23 institutions that offer 60, in total, 60 diagnostic tools for dating to analysis, including organic materials, proteomics, imaging techniques, and so on. And for the mobile version, coordinated by Costanza Miliani, that is now no more in Perugia, but is in Naples as director of the Institute ISP. 16 institutions are offering their mobile instrumentation consisting of system for-point analysis, multi- and diverse spectral imaging, remote sensing, and what concerning the Italian contribution within the program for the archives, all of the opificio is open. Concerning the large-scale facilities, there are 2 laboratories of the Laboratorio Nazionale del Gran Sasso and another laboratory, the LABEC of the University of Firenze. For the mobile instrumentation, there are practically 50% of the instrumentation, the mobile instrumentation belonging to MOLAB, now are belonging to laboratories of CNR and the University of Perugia. For the CNR contributes laboratories from Catania, Perugia, Firenze, Lecce, and Potenza. Okay, so Francesca is looking at me. Now we are at the final phase. The future will belong to Iris. At the moment, on the 14 participants to the last initiative, 8 have already signed the ERIC agreement, that is the agreement that binds the Ministry of Research of the various countries to contribute and financially support the initiative. And we have just to wait next year in order to start. If Francesca gives me 30 seconds, I just say that one of the most important work developed by Luca Pezzati, he did a lot of work concerning this, was to create the premises to create, to transform IRIS not in a European infrastructure, but a global infrastructure. Involving a lot of institutions from Asia, but also Northern American institutions, such as the Smithsonian, the Getty, and also Latin American institutions from Mexico, Argentina. Just to say, the first contacts with Latin American institutions were realized in La Habana, in Cuba, in 2007, and it was organized as a conference accompanied by a school on science and technology for cultural heritage. And there was the participation of Argentina, Brazil, Chile, Colombia, Cuba, Mexico, Peru, Uruguay. A lot of conservation institutions, Latin American conservation institutions were there. I spent these added seconds just to show you this picture, and you can see from the faces of the people there that we had not only a lot of serious work, but also a lot of amusement. Just this for Lucia that we're talking about. Okay, I'm finished.
For their contributions. Also interesting because I couldn't help but notice, Bruno, in your presentation that the investment of the European community in this endeavor was about 53 million to establish an infrastructure in the spirit of the Europeans, or just sharing our resources, matching the Mellon investment of over 50 million to endow individual scientists at individual museums in the United States. That said, we will be moving to the Metropolitan Museum of Art, where Federico Caro is hopefully ready.
Can you see me?
Yes, we can hear you,
Oh.
Federico.
Let me share my screen.
That's great, so that I don't get judged against Antonio, who was always ahead of time, and I'm already running late on this session. Thank you.
Okay, could you see the screen? Yes. So thank you, Francesca, and thanks to all of you attending this workshop today. I'm extremely grateful to the organizing committee and to the Accademia dei 40 for giving me the opportunity to present today and being amongst so many esteemed colleagues and friends. I only regret that I couldn't make it to Rome, which is a much better venue than my office here in the ground floor of the museum. This office is indeed located on the ground floor of the Metropolitan Museum of Art, where I work as a research scientist together with other, I think, 14 colleagues, some of them Italians, in a daily dialogue with curators and conservators. The museum has 17 curatorial departments which study, exhibit, and care for the objects in the museum collection. There are also 10 different specialties in conservation at the museum. There is objects conservation, textile, paper, photographs, painting, costume, library and archives, arms and armors, and Asian paintings, as well as a time-based media group. The Department of Scientific Research collaborates with all of these departments to investigate materials aspects of works of art in collection, and works with designers, registrars, collection managers to guarantee the long-term safety of the collection. To do so, we take advantage of a suite of analytical instruments that favors, as has been mentioned in the previous talks, non-invasive approaches over the invasive, which when is necessary, is indeed minimally invasive. So for instance, here you see some example of instrumentation we have, and I just want to mention in the lower left, a tarot that is being analyzed by macro X-ray diffraction is something that will be featured as my colleague Federica Pozzi a little later. So how I got here at the Metropolitan Museum of Art. My journey started from the Department of Earth Science of the University of Pavia, and you see here an image of the department, which was, it is called, I think, still La Nave, because of his design, where eventually I was able to combine my two passions, the one for art and architecture, and the one for material science and technology. And I have to confess that I don't think I was an excellent student from the start until Professor Ugo Zezza showed me, it was professor of applied petrology, showed me how I could read my own town's cultural heritage through the lens of geology. And here you can see on the left, I showing the topic of my thesis dissertation, which is the beautiful and delicate Basilica of San Michele Maggiore. Understanding this intimate connection is what has been driving my interest in studies. Although I have to recognize that spending many summer helping my father in his motorcycle repair shop has also influenced the approach, the way I approach the study of works of art. So I need to thank him as well for that. If I have to cite what made a difference in my career and what eventually brought me here in your city, I have to cite the pursuit for and the participation to many international exchange programs and summer schools that put me in contact with different research environments, different mindsets and experiences. So Erasmus program for me was very important in learning, what was out of my small university circle. And indeed, it was thanks to 21 days that I spent on a Consiglio Nazionale delle Ricerche Grants, the short-term mobility program, that I could learn about museum sciences in the US, and that's eventually why I end up here. So today, I would like to discuss about how scientific research enhances the experience of the public that choose to visit an art museum, particularly by focusing on the perception of color that I'm missing or have changed, which is something rather common for objects in museum, whether it's a faded lake in a Van Gogh painting, a hidden portrait of the Lavoisier that is not visible anymore, but it's there below layers of repaintings, or the lost patination of a polymetallic frog designed by Tiffany and Company. And to do that, I will talk about the work we've done for this exhibition. The exhibition Chroma, Ancient Sculpture in Color, gave us the chance, and I would say for the first time, to present scientific content in the gallery next to art historical information, and to give the public the possibility to look at objects from a different perspective. The flagship object of the exhibition was this Attic funerary stele, which features a youth and a young girl on its shaft, and has a capital and a final in the form of a sphinx. And the sphinx final that you see here reconstructed on the left is carved in the round from Parian marble around 530 BCE, and is one of the most extensively painted monuments in the Greek and Roman collection. And for this reason was selected by the curators for a new physical reconstruction in color that you see here by Vincent Brinkmans and Ulrike Koch-Brinkmann. The exhibition was not just about the Sphinx, but it gave us the chance to investigate many objects in the Greek and Roman art collection. Objects big, very big and small, produced from the 3rd millennium BCE to the 2nd century CE, and of different materials, such as copper alloy, ceramics, ivory, limestone, and of course, marble. And what was really important is that some of them were never studied, and we had the chance to look at them for the first time. Given the analytical, logistical, and time constraints, each object required a dedicated analytical protocol, often organized around the exhibition calendar and around curatorial needs. So that was quite a challenge. These protocols were designed to collect the greatest amount of information with the minimal intervention of the objects. So the majority of the analyses were performed non-invasively, and you can see here some action photos during the work done in preparation for Chroma, and some of the work could not even be moved from the cases where they were installed, so we have to work around that. Using a handheld X-ray spectrometer, for instance, which is a relatively common now instrumentation available in many museums, scientific research museums, laboratories, we surveyed the surface of the Sphinx in search for chemical elements that could be associated to specific pigments. So here, for instance, we were interested in the polychromy of the fly feathers and how colored alternated in the decoration of these elements. Pigment remains were imaged in the galleries using a digital microscope, which help us understanding application techniques and pigment mixtures, for instance. So here you see remains of cinnabar on the left and coarse azurite applied on the fly feathers on the right, but also provided the visitors with a direct evidence of pigments and colors, something that usually they cannot appreciate, and how they might have looked originally. And we use these images in the gallery a lot, and also for other didactic events. Similarly, we use other imaging techniques such as VIL to learn and, I want to stress, communicate about pigments that are not visible anymore with the naked eye. These images give us very important scientific information, but are also quite powerful and stimulate the public's curiosity. And here you can see where Egyptian blue is present in certain specific elements of the flying feather and not in others. X-ray fluorescent mapping was also used to understand the design and color scheme of selected areas of the Sphinx. And when combined to complementary imaging techniques such as VIL, it was essential in discriminating between different, for instance, copper base blues. In this case, azurite and Egyptian blue, both used for the decoration of the wings. With particularly Egyptian blue used to represent the light blue background in contrast to darker fly feathers. And here you can see another map, in this case of the crown, where its decorative pattern was revealed thanks to XRF. And again, we use these images a lot to convey information to the public. We all know that these non-invasive techniques provide preliminary information about polychromy, but often leave unanswered questions, such as how pigments were applied or whether or not pigments were mixed and layered. In this case, a microsample could contain wealth of information, even if it's less than a millimeter big. And here you can see a section of a small sample of the Sphinx hair with the marble surface on the bottom, the pigment layer, and the burial deposit on top. And this sample informed us that the color, the pigment was applied directly on the marble surface with no preparation, and that in this case, the red pigments of the hair consist of an hematite-rich ochre that contains traces of arsenic and scattered few particles of cinnabar as well. Such detail can be very useful when we want to correlate different objects. For instance, here we see a sample collected for the hairband of the chorus, which is exhibited in the same gallery of the Sphinx, that shows a marble surface where a hematite-rich ochre is applied directly on the marble without preparation. And interestingly enough, the morphology and the chemical composition of the hematite, which is arsenic-rich, is comparable to the one of the Sphinx. The opportunity of studying in detail several objects in the collection led also to unexpected discoveries, such as in the case of the 6th century BC horse head that bears traces of an uncommon type of Egyptian blue. And you can see here highlighted where the traces of Egyptian blue is found. You can see here. First analysis by X-ray fluorescence spectroscopy detected cobalt in high amounts of iron among the constituents of the pigment, which is something relatively unusual that convinced us to spend a little bit more time in studying it rather than rushing and providing information to the curators and conservators that were installing the exhibitions. A digital image of the pigments collected on the, from the objects shows its main constituents. You see the blue particle of Egyptian blue, the cuprorivite, unreacted quartz, but also quite abundant dark angular particles that caught our attention. And you see here scanning electron images of this particle. And by the way, we had permissions when we were able to convince the curators that it was really interesting to collect a microsample. So that's why we are able to show these kind of images. And these are some of the black particles that you see on the left image using backscatter electron imaging. And you see they varies from single particles to aggregate of particles with an infill phase. Quite interesting. These particles were characterized as cobalt copper ferrites, which are relatively minerals that rarely occurs in nature, and that are likely the byproduct of the synthesis of these blue pigments. And you see here elemental mapping showing how iron, cobalt, and copper are directly associated in these particles, and there is an infill that has a very different composition. unfortunately, I can't say much more at the moment about these findings as the project is ongoing. And we know that cobalt copper ferrites could potentially form during the dry synthesis of Egyptian blue, but we have no evidence right now confirming these hypotheses, neither the possible sources of cobalt have been postulated. However, it is clear that understanding these particles and how they end up there could help understanding the technology behind the production of this specific Egyptian blue, such as which raw materials were used and which temperature the pigments were fired, and might even help reconstructing the trade of these particular pigments. Because what we know is that there is one other and only finding of cobalt copper ferrites in an Egyptian blue small cake that was excavated from a workshop in Kos. This is a later workshop, but you see here highlighted in pink a lump of Egyptian blue that contains the same exact copper ferrite. So it's not a unique occurrence, but it has been documented before. Now we have to understand why. So scientific investigation can really help us seeing works of art under a different new light. And for the exhibition, for Chroma, scientific data was used to guide the reconstruction of the ancient polychromy of the Sphinx. And you see here an earlier reconstruction of the 1980s and the new one that it was proposed in the galleries. But also, scientific data enrich the gallery labels, can reach the information that reach the public, and could reach the public in various ways, through labels in the galleries, but also through online and scholarly publications, and even through an application that was designed specifically for the phone, where public could play and discover pigments themselves. And so trying to be scientists for once in the galleries and seeing pigments for the first time. And last but not least, we had the chance to present our work through a successful program of gallery events and talks, where we experienced firsthand the excitement of adults and kids reading art through science. And I really want to stress that as one of our goals as scientists in museums, to reach for broader audiences. And with this last slide, I conclude and leave the floor to my colleagues. Thank you.
Thank you very much, Federico, for the very interesting talk. I'm lifting some thoughts that hopefully then Marco will pick up, but it's interesting that you mentioned that as part of your inspiration to get involved with heritage science was the terroir, so just being surrounded by historic architecture and seeing how your geological training could be applied to other fields of studies. And thank you also, as with the other speakers, for presenting both an experience in the galleries and some work in progress, which is the exciting part of doing scientific research in our field, that we often have more questions than answer. I've gained 1 minute on my 2 minutes delay on the schedule, and I am absolutely delighted to present our next virtual speaker, who's very close to me. She works at the Art Institute in Chicago, Clara Granzotto, and very grateful that she's joining us today.
Thank you so much to the Accademia dei 40 for the invite, and thank you, Francesca, for the nice introduction. Can you all see my screen? Yes, okay, that's good. As Francesca said, I'm the Associate Conservation Scientist in the Conservation and Science Department at the Art Institute of Chicago. And I would like to start my presentation by talking about one of the latest projects I've been working on, which is about the characterization of painting materials on bois masks from Burkina Faso. So we are in Burkina Faso, West Africa, and the masks I've been studying are the masks that you can see on the right of this slide. So these are masks belonging particularly to the Bois people. They are usually made of plant fibers, but in this case, they are carved in wood. So Bois masks are usually two-dimensional. They have these characteristic geometrical patterns, and they are painted with three colors, black, red, and white, which evoke the three major rivers crossing Burkina Faso, the black, red, and white voltas. So these masks are used in different occasions. They are, for example, used during initiation of a new family member, during funeral, during the introduction of a new mask to the community, in connection of rites for the harvesting cycles, but also during performances in the market days, both for the villagers and nowadays for tourists. They are usually held by the dancer through a rope in their mouth, and they are then attached to a body costume, which is often made of plant fibers. So when we started this research project, we studied the literature, and we definitely got a lot of information about the possible materials that could have been used to paint these masks by accounts of scholars who worked in Burkina Faso. And among these scholars, I want to mention Christopher Roy, who has been working in Burkina Faso for over 40 years. So according to Roy's notes, for example, the black paint is prepared by boiling seed pods of the tree Acacia nilotica, or other time by using powdered charcoal, which was mixed with a binder such as egg. For the white, excrement of lizards or snakes were used, or simply some schoolroom chalk. Red instead consisted in iron-rich stones such as hematite, mixed again with a binder that could be an acacia gum or egg. However, Christopher Roy, together with other scholars, also mentioned recently the introduction of more modern materials such as enamels. So in this study, we combine spectroscopic and mass spectrometric techniques in order to better characterize these painting material. But we were lucky enough to be able also to get in contact with Abdoulaye Oudrago, who is an artist from Boni in Burkina Faso and an expert in mask making. So, of course, with scientific analysis, our goal was to corroborate and complement the information that we had from scholars. But by combining scientific information with artistic knowledge, we were really able to move a step further to really get a better idea, not only of the nature of the materials used, but also how they were prepared, selected, and applied. In addition, there is a sort of an impetus for scientific analysis, since there is a growing interest on bois masks from Western institutions and collectors. And so it's very likely that artists will move from more traditional materials to more easily available materials. So let's start from the black paint. When looking at the samples under the microscope, we could tell that this black paint was really had a really translucent appearance and more of a sort of a brown color. So as we usually do, we start with a very fundamental screening technique, FTIR, and results show the presence of tannic acid, which was consistent of the use of some kind of tannin, so a plant-derived polyphenolic compound. And this was also confirmed by pyrolysis gas chromatography mass spectrometry, thanks to the identification of gallic acid and ellagic acid, which also helped us understanding a little bit of which kind of tannin we were dealing with. And in this case, because of these two compounds, we were dealing with hydrolyzable tannins. However, in order to corroborate the tannin source, as mentioned by Christopher Roy and other scholars, we decided to purchase some acacia nilotica seed pods and to do some cooking in the lab. So we boiled these seed pods in water for several hours. We took the extract, dried, and analyzed it by FTIR and pyrolysis. And the results were extremely similar to the results that we got from the black sample. And this was a confirmation of the use of tannin to prepare this paint material. However, we couldn't really understand why our extract didn't really look as dark as the black paint on the mask. And that's in this moment that our conversation with Abdullahi was extremely helpful, since he told us that usually the extract is then boiled even for several days in order to get a concentrated and darker product. So while with this experiment, of course, we couldn't determine and prove that acacia nilotica was the source of tannin, since tannins are present in many different plants. However, we were still able to support the account of the source of the paint and also the way of preparation. Moving on to the red paint, FTIR analysis and some EDS analysis confirmed the use of hematite. But the most interesting part of the story concerned the paint binder. So as you can see on the left, FTIR analysis indicated the presence of a protein-based material, but there were some features suggesting also some sort of lipiding compound, which could be related to an oil or most likely to, for example, egg yolk, which adds 30% content of lipid content. And this was sort of confirmed by pyrolysis, according to the proportion of the different fatty acids and the low level of azelaic acid. But maybe because I am an organic scientist, of course, I wanted to go further. And so we decided to move on with sort of kind of recent technique, which is mass spectrometry-based proteomics. As mentioned before at the beginning of this afternoon session, proteomics has been introduced in the field of cultural heritage a little bit less than 20 years ago. So it's a pretty recent field. And the great potential, the great power of this technique is that we can get information not only about the type of proteins that we have, but also, if we are lucky enough, about the species of origin of the protein. In addition, this is an untargeted technique, meaning that we don't get information only about the proteins that we expect to find in cultural heritage samples, such as animal glue, egg, or casein, but we can see any kind of protein present in the sample. And this is extremely important when working with, let's say, non-Western materials that have not been scientifically studied as much as our common samples. And we were lucky enough to get a huge number of proteins. We saw some egg white proteins, egg yolk proteins, suggesting the use of whole egg. And in particularly, these egg proteins were coming from a specific bird called the helmeted guinea fowl. I was not aware and I didn't know this bird, but apparently guinea fowl is native of Burkina Faso. And in one other red sample, instead, we found a mix of egg proteins from both the guinea fowl and the wild turkey, which is, of course, not native of Africa, but was introduced in Africa and before that in Europe during the 17th century with the Spanish colonization. And again, here, by talking with Abdullahi, he mentioned that, of course, the use of eggs from guinea fowl is very common because it's present in the village, but sometimes in absence of these eggs, they will mix and use any kind of eggs, including eggs from wild turkey. And finally, the last paint material, the color white. So when looking at the masks, All the white areas looked pretty much the same. But scientific analysis really provided the greatest variety of materials. So in 3 out of 4 of the masks, we saw the use of kaolinite and gypsum, so most likely classroom chalk, without any binding medium, which was very, very surprising to us, because we grew up learning that usually a paint material is a combination of an inorganic material mixed with a binder. And again, here Abdoulaye confirmed that usually the white pigment is simply wetted with a little bit of water, applied then with a finger or a feather to the surface. And because the wood used to carve this mask is very soft, this is enough to guarantee the adhesion of the pigment to the surface. However, for one of the masks, the fish mask, FTIR and the pyrolysis gas chromatography showed the presence of uric acid, which is consistent with the use of reptile or birds' excrement. So both birds and reptiles excrete nitrogen in the form of uric acid or its salt, so urate, on the contrary of mammals, which excrete nitrogen in the form of urea. And I'm pretty sure that a lot of you are familiar with the natural white pigment that you see on the rocks, on some rocks at the seaside. Application of proteomics then allowed us to exclude a bird origin of the excrement and suggested instead the use of lizard excrement, as suggested and read in the accounts of different scholars. And again, here when talking to Abdoulaye, he mentioned that these lizard excrements are collected in nature, for example, in the cave, but it's not common practice nowadays. And so again, scientific analysis was extremely helpful in this situation to distinguish masks where more traditional materials were used instead of more easily available materials such as gypsum, while from a first observation, these masks looked exactly the same. And so by combining information from scholars, but also information got during our conversation with Abdoulaye, and scientific analysis, we were really able to get a better understanding of the materials, of their use and application. And this research, with this research, we also want to stress how important it is when working with non-Western materials, when possible, to get in contact with the community, to be sure that we as scientists can actually investigate these artworks and in case publish the data. In the second part, I wanted to summarize a little bit my journey from the Ca' Foscari University of Venice to here, to the Art Institute of Chicago. It's a journey that required crossing the Atlantic Ocean several times and get adjusted to different languages, different food and bureaucratic systems. But definitely every step of this journey helped me approaching in the best way and understanding which was the next step necessary to become a conservation scientist. And so I wanted to touch and talk a little bit about some of these steps and the lessons that I learned. So as I mentioned, I studied in Venice. There was a program called Chemical Science for Conservation and Restoration. It was a 5-year program, so I did both my bachelor and master. And back then, so I started 2004 until 2010, we were under the chemistry department. And to me, that was very, very important, meaning that when I graduated, I had the title of chemist. This gave me, first of all, an incredible scientific background that then I used during my whole journey. I had a title that allowed me to sign up and apply to a scientific PhD. But also, to be honest, I had the possibility to have a plan B. When I was during college, I didn't know any conservation scientists. I didn't know if I could actually become a conservation scientist. So if I couldn't really reach my final goal, of course, I had a title that allowed me to go and work for a pharmaceutical company. I'm glad I didn't. Another important point of this program was the numerous conservation labs. We had labs of painting conservation, wall painting, metal conservation. Besides learning a lot of conservation procedure, the most important thing is that I learned a language that helps me now to discuss and interact with my colleagues in the conservation department, and also to build a fruitful collaboration with them. One thing that back then we were sort of missing was, however, kind of connection with the international context. As I mentioned, I didn't know any conservation scientists, and we were not aware of internship and fellowships abroad outside of Italy. And to be honest, the internship that I had at the Met and followed them by fellowship was the most eye-opening experience I ever had. For the first time at the Met, I met some conservation scientists. And so I realized that, yeah, maybe I could be one of them. I was able to work on several different projects to understand what I liked, to understand what, in which kind of aspect in the field were missing some research. And this helped me decide in which direction to take for a PhD. And also that I actually needed a PhD to become a conservation scientist. Another important thing in my career was the application to European fundings. I was lucky to be awarded Marie Curie individual fellowship. And the fact of going back to university really helped me to build a know-how and an expertise, which was very focused. But on the other side, I was able to get an expertise again that could be of interest for my future employer. Also, European fundings really help to have money to travel and so create collaborations and do networking. And I'm finally here at the Art Institute of Chicago, and I could have not done it without all these different steps. And so I want to thank everybody who I met in my path, and just a last picture to show how sometimes we end up sampling the object, and this is one of the masks I showed you before. Thank you so much.
Presentation. In the interest of time, we'll continue with the program, and hopefully some of you are here still during the roundtable. We can have a conversation. Just a couple of things that I wanted to highlight again in terms of your path. These themes of international collaboration and networking, and how formative that is for us in the field. I think it's also very important to underscore. And also, I certainly speak for myself, but I've heard Marco say this. It's not that we hire Italian scientists because we are Italian. We hire Italian scientists because they're really good. We also hire other scientists. And on this theme, let me introduce Monica Gagno, who is officially the speaker who has traveled the farthest to come here to Rome. And I'll leave the floor to you, Monica, to talk about your project and introduce yourself. Thank you.
Good afternoon, everybody. Can you hear me well? I'm Monica Gagno. I'm an associate scientist at the Getty Conservation Institute, which means I'm 9 hours out of my comfort zone, and it's supposed to be 6 a.m. for me right now. But everything is good. Today I will talk about archaeological glass, which is, I would say, my passion and something that has been constant in all my steps throughout the world. And so I will start by indeed talking about the path that took me to the Getty Conservation Institute. I started in Turin, where I studied glass over there, and I did the same program that Eleonora did. Indeed, we were classmates, Science and Technology for Cultural Heritage. I did both my bachelor and my master there. And I think that one of the biggest lessons I learned from that place is the solid foundation on heritage material, and the fact that you need a a perspective that is very coming from multiple disciplines to understand the complexity of the material. After this, I went to the Getty for the first time, and I did an internship there over a year. My supervisor was Mark Walton, and as such, I was lucky enough to continue work on some vitreous materials, but I was also exposed to many other materials, namely archaeological stuff for the majority, but also some more modern and recent issues, such, for example, this pink staining on marble that was a consequence of a past treatment. And over there, I think that the takeaway is the need of a good communication and understand the language and being able to express your point of view and understand what the conservator and curators are asking you and try to make the most out of it. To keep on working on glass, I moved back to the old Europe, and I moved to Leuven in Belgium, where I did my PhD on archaeological glass and understanding the provenance of archaeological glass and their raw materials. And that was mostly focusing on one aspect, deep dive into it, and definitely learning to manage an independent project and be aware of my timing and how to deal with different organizations and institutions. I then was very lucky to go to Chicago, where I worked again with Mark Walton and Francesca at the New Access. Similarly, some were glass, but also very different materials, some archaeological and some totally non-archaeological materials, such as those modern sculptures, bronze sculpture. There, definitely, the word that comes to mind is multitasking, because one person, many different projects all together, so the ability to change very quickly what is your daily schedule. And then lastly, I am back at the Getty Center starting in 2015, where I work mostly in the archaeological section at the Getty Villa. And there, I would say the word is flexibility, again, for the reason that we really work in collaboration with the conservation department, and it really depends every day. Most of the time, if I have a plan, oh, today I will do this, surely it's not going to happen because a new thing comes in the lab, and so it's a switch, very quick switch. Having said this, I will go back to my project, the archaeological glass that I was discussing before, and as I'm not sure how much people in the audience know about glass, which is probably not the most common material that we discuss in these conferences, I will give a very, very brief discussion of this and say a few words. So glass is generally created in a two-step process. You have a first step where you mix the raw ingredients, being sand, a flux, and a stabilizer, and you obtain the so-called raw glass. This raw glass is generally not colorless. It's always has a pale tint, can be pale blue, pale green, pale yellowish, depending a little bit on the impurity of the sand. And then you have a second step, which is the glass working. That doesn't necessarily happen in the same location at the glass making, where the raw glass is melted again, and there are a series of metals that are added as colorants or decolorants, and you finally obtain the nice, pretty object that then we want to see. So this was the methodology used most throughout the antiquities, and it's very well known and characterized for Roman glass, but it was similar also before and even a little bit after. Now, the project in particular that I'm talking today deals with core-formed vessels, which are those iconic little glass objects, unguentaria, also very often called, which are very bright colored, most often blue with striation of yellow or white and turquoise and different patterning, very geometric. Those were produced in a relatively narrow time range, being between the 6th and the middle of the 1st century BCE. And they are very often called the Mediterranean group vessels. There were three main locations for their production that changes over the time, as I am indicating. So it starts in Rhodes, then moves to Magna Graecia, so southern Italy, and then moves to Cyprus. And these three large group, or mostly period, are often called Group 1, Group 2, and Group 3. And we are going to call and mention and so remember this knowledge very briefly. Those are some of the objects that I had the pleasure to study. They are all up to dimension, so you can see there are different shapes. different sizes, different colors, and different level of preservation and alteration given by the natural weathering. I want to stress one thing about the shapes. This, I would say, they are really the extent of the shapes that were produced, because throughout the 6th century, this group of objects are characterized only by 4 different types, which being the amphoriscos, the ariballos, the onyche, and alabastron. Now, to me, they look all very, very much similar throughout the century. Art historians will have a very different take. So indeed, I found a quote in one of the catalogs describing the object that was saying that the small dimension difference of the handle, it's clearly pointing to a 2nd century versus a 6th century. To me, was absolutely not different and intelligible, the difference. So just saying different perspectives are important. The reason why we did this project was mostly to understand what was the colorants and the opacifier, and potentially understanding something better about the chronology and the composition, and say something about the provenance. This for 2 reasons. The first was a scholar named Tassos Antonaras, which is a prominent scholar in the study of archaeological glass, is currently writing a catalog of the glass collection at the villa. And we worked together and we selected some of the objects that for him were a little bit more complicated to understand or to explain and describe, so to gather more information and help him in the dissemination, but also to get some better information in the near future, hopefully, on our website. So this is how a typical description of an object looks on our website. The description, it really is not very good. It says 200 to 1 BC, unknown artist, clearly. And if you look into the detail, it tells you the dimension. It says there is glass. That is potentially Greek, although culture, it's a little bit complicated because the objects that they get are classified as Greek or Roman. And it comes from Eastern Mediterranean, which is a very generic place for something that is a Mediterranean glass. So we would need to know a little bit more potentially. And then I want to discuss the analytical strategy. So I'm showing here a bunch of little fragments. This is what, when I first started to study glass, was presented to me. So I have a bunch of fragmentary material offered by university excavation or archaeological collection. And those are material that essentially are waste because no one could really use them to reconstruct a shape. So the amount of information you can gather is incredibly large for what concerns their chemical information, but there is a little bit of a lack in what is their shape, how it was created, what was the use of it, and so on. On the other hand, when we look at a museum object, like full, complete museum object, very, very often I don't have the luxury of sampling, hence I cannot do ICP-MS, I cannot do microprobe, I cannot do isotope analysis and all of this thing. And even laser ablation, most of the time I really can't do it because the object is too big to be placed inside the chamber. And in addition to this, if I look at a multicolor vessel, I will need to do multiple spots, hence create something visible to the eye. My institution doesn't allow it. So what I see is that instead of having a balance between these two situations, I actually have a bias towards material that is fragmentary, and I know a lot less about those materials that survive the proof of time, essentially. They have a complete history. So the idea was to try and use XRF, which has a lot of pros, but has a lot of cons in the study of glass, especially. We cannot have any information about light elements for real. So magnesium, potassium, aluminum, silica, all those elements that are really characteristic of the base glass are not going to be really well analyzed because of issue with the technique itself. On the other hand, I could steer the question that I was asking and just focusing on the colorants and opacifiers, so understanding the technology of the secondary workshop, essentially. And the way I decided to do was to do XRF on the object and then take the full spectra without calculating anything, literally this spectra, and throw it in a principal component analysis. And do PCA on the spectra itself and try to see if this was enough to distinguish large categories. So here I'm showing some results. And I'm showing first PC1 versus PC2. I decided to stop at the first 3 PC that I will show in a minute, just because after that it became very noisy and it was really hard to see if it was something real or if it was just essentially noise. So the loading plots on the bottom right show me that I have some variations. So for example, PC1 shows a positive lead, while PC2 positive copper and a negative manganese. If I transpose this to my scores plot, you can see that there is some differentiation. The little dots you see correspond to the color of that I can see with my naked eye. Sometimes the color, for example, I'll give you an example. Here there are some white spots, which I think are actually indicative of an alteration of the glass itself. But you can see, for example, the yellow stay on their side, and then potentially you can say that the turquoise are on the upper section, while the purple are on the bottom and are richer in manganese, which is all kind of reasonable, but it really doesn't show me any wonderful groupings. I wasn't particularly pleased. So went along, did the same thing, PC1, PC3. The situation changes slightly, so we have a division between the blue and the white and turquoise, but now white and turquoise are overlapping, so it's again not completely clear. So probably a little bit better is when we start looking at this PC1, 2, and 3 together in a three-dimensional space. And we can see, for example, that the blue and the turquoise and the white are indeed separated on along PC2, but I overlap along PC3. The yellow are by themselves, and then the blue are kind of a mystery, which we're gonna discuss. So I'm showing just one example for the white and the turquoise. And for example, if I take into account the white, I would distinguish these four little clusters. If I look at a characteristic X-ray spectra for such, I can see major differences, being the one that is in red is characterized by the presence of antimony, but especially by the complete absence of lead, which instead is what characterizes the other two. This will suggest me that there is a change in the technology for the production of the color white. And more interesting, if I look at the chronology, this goes together with time period. So antimony rich in the earlier period and moving to lead rich in the later period. Similar thing happens to the turquoise, and this is kind of reasonable given that literature describes the production of turquoise as the addition of copper to a white base glass. Now I said the blue were a little bit more complicated or less clear, let's put it this way, and this is because they are spread a little bit and it's less clear. Now, if I think of how I produce the color blue, there are two main ways to produce blue in a glass. It's using the colorant cobalt or the colorant copper. Now, cobalt is added in very small amounts, in the order of 0.5 to 1% maximum, otherwise the color becomes so dark and deep that you don't have a transparent glass anymore. Copper instead, it's on a little bit higher concentration, but not particular. It's not a major element. It's still going to be a minor element. Both of these colorants come in with a series of trace elements. Now, if I do XRF and I need to look at a trace element, perhaps in the order of some 100 ppm, in something that is already only 1%, it's really hard. So I am missing all this information. And on top of this, there is one more thing to add, which is the extent and the role that recycling plays into the production of glass. Very similar to what we do today. If you look at this scheme, there is one part that I was keeping out, which is recycling. So as you would do today, and you would take your scrap of glass that are broken, put it in and recycle them, same thing was done in the past, even more because it was very time-consuming and material-consuming product. So they were trying to selectively introduce cullet of glass of the same color that it was produced. Now, you can easily understand it. If you want to produce a colorless glass, probably you would not add a piece of blue glass into this, because then you have to work so much to get the color out. But if you do the opposite way and you want to achieve a blue color, honestly, if you put a little bit of this or a little bit of that, most likely it's homogenized by the darkness of the color. It's what was suggested and experimented by Jackson and Painter. They produced a modern replica of one of those vessels, grind it up, and then melt it again. And you can see in the grinding that there are some little bits of yellow, which, if you remember, were lead rich. When you do the melt, it comes out a color that is pretty much the same, but has higher content of lead. And so if I go back to the PCA analysis result, I can see that the going towards positive PC1 have an increase in lead. And so I can hypothesize that perhaps those samples that are marching towards that direction are influenced by recycling. Now, this is as the extent as the XRF can tell me for real without crunching numbers and start doing some calibration and calculation of semi-quantification, which I really wanted to avoid because of the reason of not being sensible enough. And I hope I was able to show you that even with just an instrument that is not generally considered the best for this type of analysis, we perhaps can swing this bias and try to analyze and gather more information from museum object and increase our knowledge and everything else that they can tell us beside what we already know from little scraps of glass. This is a little video that I'm leaving you on the production of those core form vessels, which I think is very exciting, and I thank you all.
Thank you so much, Monica, for a fascinating talk. And again, I cannot fail but notice the squiggly career path that Gianluca Pastorelli also had in his graphic, as well as this emphasis on ability to communicate as one of the requisites for being a successful heritage scientist in a museum. And also, as Clara showed, this pattern of transatlantic crossing back and forth. And so it's wonderful to close this session with my colleague, Federica Pozzi, who has done this several times and is probably the most successful example of the rientro dei cervelli, the returning wave of the brain drain of Italian scientists, because after an illustrious career in the United States, she's now back in Torino at the Venaria, and this is also the title of her talk about building bridges. And so, Federica, here to you.
Thank you so much, Francesca, for this very nice introduction. The case study that I'm going to talk to you about today is actually very dear to my heart, and I will tell you everything about it in just a second. Just like my colleague speakers earlier, I was asked to introduce myself and share a brief overview of what were the fundamental steps that brought me where I am today. So I'm going to try and do this in one slide. So between 2003 and 2012, I got my Bachelor of Science, Masters of Science, and PhD in Chemistry and Chemical Sciences from the University of Milan. That was probably the place where I had my first work experience in an analytical chemistry laboratory. And where I got acquainted with several spectroscopic and chromatographic techniques. As part of my PhD studies, I was lucky enough to spend 1 year working in the Department of Scientific Research of the Metropolitan Museum of Art, where I worked with Marco on the development of methodologies and databases related to a particular analytical technique called SERS, Surface Enhanced Raman Spectroscopy, that is particularly suitable for the ultra-sensitive detection and identification of organic colorants in works of art and archaeological samples. In 2012, I had an appointment jointly with the chemistry department at the City College of the City University of New York and the DSR department at the Metropolitan Museum. So I was able to continue my research on the development of SERS methodologies and databases with applications both to conservation and conservation science, and also to the field of forensic science. Between 2012 and 2014, I was a postdoctoral fellow in conservation science, working with Francesca at the Art Institute of Chicago. My focus was a technical study of 19th century French Impressionist and Post-Impressionist paintings from the museum holdings. I also collaborated with Northwestern University, and specifically with Richard Van Dyne's group at the chemistry department, again, continuing to develop non-destructive source methodology for the analysis of dyes. Between 2014 and 2016, I was first a postdoctoral science fellow and then an assistant conservation research scientist at the Guggenheim back in New York. So the Guggenheim had a very strong conservation department, but no scientists on their staff or scientific research facilities to conduct technical studies of objects in their collections. And so this was a wonderful pilot program, also in collaboration with the Met DSR, trying to establish a framework for science and science-informed conservation where none existed before. I went back to the Met Department of Scientific Research in 2016, where for 5 years I was an associate research scientist, and I led a wonderful initiative called NICS, the Network Initiative for Conservation Science, that was mentioned before by Francesca, whose goal was to provide analytical assistance and scientific support to a core group of partner institutions in the city of New York that, again, didn't have scientists on their staff or research facilities for technical studies of their objects. And so we had a chance to collaborate with 11 museums in the cities. They include the American Museum of Natural History, the Guggenheim, MoMA, and many others. I moved back to Italy after 11 years abroad 2 years ago in July of 2021 to work at one of the 3 conservation centers in the country, the Centro per la Conservazione e il Restauro dei Beni Culturali La Venaria Reale, where I currently serve as director of their scientific laboratories. So I'm sure we will get a chance to discuss further about this and the importance of the education that we got at the Italian university. In my case, I think what I want to say, it's been very interesting for me to reflect on my own journey. That's been some sort of a circular journey. So because of my strong scientific background that I acquired at the Italian university, I was able to secure my first position at the Metropolitan Museum, and then I had many other opportunities after that for the next 11 years. And then because of the great experience that I acquired working in many US museums, I was actually offered a position back in Italy at the Centro Conservazione e Restauro. Okay, so coming to my case study, I'm going to speak about a technical study of 15th century Italian illuminated tarocchi cards. This has been a great project, very much international, multi-institutional, and with a highly collaborative component. There are many people, many great colleagues and friends and institutions as well that I need to mention that are currently partners of this project, such as the Morgan Library and Museum, Yale University, the Metropolitan Museum, the Centro Conservazione e Restauro La Venaria Reale, as well as the National Gallery of Art and the Art Institute of Chicago. As you probably can tell by looking at this timeline of research activities and collaboration, the research project has been going on for quite a few years now. It all began from an informal conversation back in 2016 between 2 conservators, a conservator at the Morgan Library in New York and a conservator at the Beinecke Library of Yale University. The research project grew over the years to become a fully fledged, pretty complex research project that survived the global pandemic starting from 2020 and is still going on today in 2023. So I thought I'd start with the definition of the term tarocchi that we now use in a completely different meaning compared to the 15th century. So back in the 15th century, the term tarocchi was used to indicate a trick-taking card game that appeared for the first time, again, in the first half of the 15th century in northern Italy. So the term tarocchi was not used to indicate divination activities until the end of the 18th century. And conventional tarocchi decks actually contain 78 cards divided between pip cards of the 4 different suits, so cups, coins, batons, or staves, and swords, court cards, including the king, the queen, the knight, and the page, and the so-called trump or tarocchi cards, including, for example, the emperor, the fool, death, sun, and many others. So these are the three tarocchi decks that I'm going to focus on today. They're collectively known as Visconti Sforza tarocchi decks. They're divided between United States and Italian collections, and in particular, the Visconti di Modrone deck is at Yale University at the Beinecke Library. The Brambilla deck is at the Pinacoteca di Brera in Milan. And the Visconti Sforza or Colleoni Baglioni deck is divided between the Morgan Library in New York and the Accademia Carrara in Bergamo. None of these decks is a complete deck of cards. As you can see on this slide, the Visconti di Modrone has 67 extant cards, the Brambilla deck has 48, and the Visconti Sforza has 35 at the Morgan and 26 in Bergamo. So these decks are collectively attributed to Italian artist Bonifacio Bembo and his workshop, who is believed to have created them between 1331 and 1358. There are 6 so-called replacement cards that you see at the bottom of this slide. 3 are held by the Morgan and 3 are at the Accademia Carrara in Bergamo. So these are cards that were produced to replace cards that have gotten damaged or lost over time. And they were produced by 2 different artists, Antonio Cicognara, or more likely Franco di Giovanni De Russi, most likely a few decades after the regular Bembo cards. We're looking at a very important commissioning, so the Dukes of Milan, specifically Filippo Maria Visconti and Francesco Sforza. So what was the goal of our research project? We wanted, first of all, to identify and compare the materials and techniques of the 3 so-called Visconti Sforza tarocchi decks in the different United States and Italian collections, going through their layer structure, so studying the paper support, the preparatory composition, the ball and the metal leaves, the gilding and tooling, the color palette, and highlighting any potential later intervention. We also wanted to compare the materials and techniques with 3 different artistic productions that are believed to have affected the materials and techniques of these decks that are fresco painting, manuscript illumination, and panel painting as well. So overall, we just wanted to contribute to the ongoing conversation about the provenance and attribution of these decks. And also we wanted to verify whether different attributions could correspond to a different use of the materials and techniques. For the purposes of these talks, I'm just going to focus about some of the main results that we obtain on US cards, so mostly Yale and Morgan decks. Here's a brief overview of the analytical methodology and instrumental techniques that we were given access to for this technical study. So as you can see, it was a complex analytical methodology that involved non-invasive imaging techniques, non-invasive point techniques, the removal of a selected number of microscopic sample, and analysis with minimally invasive instrumental techniques as well. So in the next few slides, I'm just going to give you a very brief review of the main highlights of the main results that we were able to obtain, again, going through the layer structure of these wonderful objects. So we discovered that both Yale and Morgan cards were made on pasteboards that were fabricated by layering and gluing together 4 to 5 sheets of paper. As you can probably see from this figure, the back of the Yale cards was left bare, while the back of the Morgan cards was painted red with an organic colorant called sappan wood. We detected 6 similar watermarks on the Yale cards, and all these watermarks matched watermarks found in repositories within a 400-kilometer radius of Milan, and they were all dated between 1337 and 42, which of course is very important to reinforce provenance and attribution. We couldn't find any watermarks on the Morgan cards. In terms of preparatory composition, we highlighted the presence of a series of sequential steps, starting with a loose underdrawing that was executed with lead point. That was likely followed by an ink underdrawing that was probably made to refine the preliminary sketch. we found a series of incisions in the paper, probably created to outline certain compositional elements. And incisions and tooling was also made after the metal leaf was applied. And that's particularly clear when we analyze these cards with RTI and also visible photography in breaking light. There was a thick ball layer that was used to adhere the metal leaf to the paper support. In both decks, this ball layer was composed of an iron-rich clay mixed with or applied over gypsum. And as you can tell from the mercury XRF elemental map that I reported here, the Yale deck is also characterized by the presence of vermilion that was probably added to the ball formulation to impart a certain tone to the metal leaf. The most interesting results were obtained in terms of application of the metal leaf to the different decks. So just by looking at the gold and silver elemental maps that I put on this slide, you will probably notice some substantial differences between the two decks. So the figure cards refer to the Yale decks are gilded with small pieces of gold leaf. You will probably see they partially overlap each other, and they were applied around each figure and shape very carefully. The Morgan figure cards at the bottom use an entirely different material. So you see there is a gold and a silver overlapping distribution in the XRF maps, which indicates the use of a so-called oro di metà, which is a particular material of which 15th century Milan was known to be a big center of production of. So oro di metà was made by hammering together very thin leaves of gold and silver into a single leaf. If we look at the PIP cards at the center of the slide, so Yale cards are made with silver leaf, and the Carrara Morgan cards are made with lead white, while gold was only used to outline certain small details of the different suits. Over to the right, you can observe some beautiful micrographs that I've taken of some of these cards, highlighting the decoration that was made with punch marks of different shapes and freehand incised lines as well. We've done quite a lot of work also trying to identify the pigments and colorants that the Tarocchi artists used. And to do so, we combine different elemental, electronic, and vibrational techniques, mostly point and scanning XRF, reflectance imaging spectroscopy, and Raman and SIRS spectroscopies as well. So over here, I just report some of the most representative XRF elemental maps that indicate the presence of pigments containing mercury, iron, lead, tin, cobalt, and copper. These data were integrated by RIS analysis that we used as a preliminary step for Raman and SIRS. So by now you know everything about this technique thanks to Francesca's talk, but basically what you're looking at is some spectral end members that can be used to produce a false color map that you see for these two cards at the left of this slide, that basically indicate the distribution of different inorganic and organic materials as well. In our case, it was interesting, for example, to put forward hypotheses in terms of differentiation between plant-based organic colorants and insect-based organic colorants. And we were able to verify our hypothesis by using vibrational analysis with Raman and SIRS. So again, over here, you're just looking at some of the most representative Raman results that we were able to obtain. So we found many different inorganic pigments representative of many different colors, so vermilion for the orange and red, Latin yellow type 1 for the yellows, a tin sulfide, mosaic gold, which was a brown pigment that we only detected for the 6 replacement cards, so that was interesting. A mixture of yellow and red ochres for some of the dark yellow highlights. A combination of 3 different blue pigments, azurite, lapis lazuli, and smalt, that were often used in combination and in a very much of a complementary way, as you can see from the combined cobalt and copper XRF map at the bottom. And then for green colors, we detected malachite, an unknown copper-based pigment, together with Latin yellow type 1. So especially the Morgan cards as opposed to the Yale cards, display a wide variety of red, purple, and violet colors that were mostly of organic nature. So using SIRS, we were able to conclusively identify 2 plant-based colorants, sappanwood or verzino, and folium or morella, and 1 insect-based dye as well, kermes or grana. And again, this is something that I really want to mention because SIRS is a technique that I really focus a lot of my years on, especially during my PhD and during my early years of postdoctoral research. So using, again, a combination of analytical techniques, we were also able to detect some red lake pigments that have now disappeared. So for example, if you look at the 10 of batons in the Yale deck to the right of the slide, you will probably see in the close-up here at the bottom, a series of very fine incised lines in the shape of feathers surrounding the golden part of the batons. If you look closely, you won't be able to detect any trace of red lake, so the colorant is mostly gone. But if you look at the potassium map, you will see a distribution of potassium in the shape of feathers that is really indicative of the substrate, the inorganic substrate used to make the red lake. So in collaboration with our colleagues at the Art Institute of Chicago, we've done a lot of organic analysis. So we've done FTIR, preliminary analysis, just to understand the generic molecular class of the binders and glazes that we were looking at. And then using mass spectrometry-based proteomics, PyGCMS and MALDI, we were able to detect protein-based organic binders containing chicken whole egg for both the Morgan and Yale decks. After I moved back to Italy in 2021, I was able to involve some of the Italian museums that hold tarocchi decks in their collection, so the Pinacoteca di Brera and the Accademia Carrara in Bergamo as well. So there has been quite a lot of work done on those tarocchi as well over the past 2 years. So what you're looking at over here is just a selection of pictures from some of the analytical campaigns that we had in the Centro Conservazione e Restauro back in June of 2022, when a selection of 15 tarocchi cards from Bergamo were shipped to our institution for in-depth scientific analysis. And then in April of last year, we received the visit of a small group of colleagues from the Morgan, from Yale, and from the Met. They came to visit us so we could study the cards together. And between June and October of 2022, we also conducted a couple of in situ analytical campaigns of the Brambilla deck in Milan at the Pinacoteca di Brera. We are now in the process of interpreting the results, but I'm just going to give you a little spoiler here. So if you look at this card, the 3 of staves, from the Accademia Carrara deck, we detected a very thick carbon-based underdrawing that is not present in any of the other cards that we analyzed. And we also identified a series of very unusual materials, like, for example, organic yellows, and a combination of red ochres and vermilion at the back, that we didn't find in the rest of the deck. So all these observations made us think of possibly a different hand and time of production of this card compared to the rest of the deck. We've been disseminating our research findings. So a tarocchi virtual study day was organized back in June 21st of 2021 that was attended by more than 200 people. For those of you who are interested in learning more about this project and would like to hear the talks that were given at the study day, I invite you to check out this link at the top of the slide. We are now in the process of publishing our first article describing especially the aspect related to collaboration of this wonderful project. So the article will be published hopefully by the end of the year and available to everyone to read on the Material Getty Journal. And many, let's say, technical articles will be published hopefully in the next few weeks and months. We've also talked about possibly holding a joint exhibition of the tarocchi decks sometime in the next 3 years, hopefully in 2026, so stay tuned for more updates. It was just me today talking about this wonderful project, but of course it takes a village, especially when we talk about such complex projects like the Tarocchi research project. So I have many colleagues, friends, and institutions that I would like to thank for the wonderful work that we've done together. And I also want to thank Marco and Francesca for giving me many great opportunities over the years and for being wonderful mentors to me. And of course, thank to you for your kind attention.
Thank you, Federica. I think we're at the end of this afternoon session, and looking into the break, I just wanted to say a couple of words, even though Marco and Gennaro officially will close us, but I am absolutely thrilled because all of the speakers suggested their own topics, and I think that today, I hope you will agree, we've seen a breadth of techniques, objects studied, and interest that is quite astonishing. And at the same time as the excellence of the science that has been presented, really wonderful. And also the interesting part, I think, that has been elevated for me is the importance of the 3 C's: collaboration, communication, and curiosity. So I want to definitely extend my thanks to all the speakers of today, especially, I have to say, the remote speakers that are not benefiting from this beautiful setting we have in Rome, and myself personally thanking Gennaro Marino and Antonio Sgamellotti for inviting me to be part of the conception of this gathering. Don't go away, just keep thinking about these things, because then Marco will lead us in a panel discussion just after the break. So we will reconvene here in about 20 minutes. Thank you.
Buonasera, grazie per essere ritornati e soprattutto per avere tenuto il tempo delle presentazioni come stipulato dai nostri chairperson. Vorrei chiamare qui con me per questa tavola lineare, conclusiva, 4 tra i colleghi di oggi che rappresentano esperienze diverse e aspetti diversi per cominciare questa discussione su ovviamente coordinare il lavoro, la presenza degli italiani all'estero con quella della scuola italiana, del sistema italiano, di quello che sta succedendo in Italia, che è poi la base, le fondamenta da cui arriviamo noi italiani all'estero. Quindi volevo chiedere a Monica Gagno, Francesca Gabrielli, Federica Pozzi e Marcello Picollo, che è venuto da Firenze apposta per questo, di raggiungermi al tavolo. E Lucia questa mattina ha parlato delle qualità essenziali nella scienza per il restauro, quindi la curiosità, lo scetticismo, io aggiungo la capacità di improvvisare. Quindi i miei colleghi non sapevano fino a questa mattina che li avrei chiamati a far parte di questa discussione, però penso che rappresentino esperienze importanti. Abbiamo detto Federica, dopo questo percorso internazionale, è tornata in Italia. Monica rappresenta anche lei un percorso internazionale che è ben radicato negli Stati Uniti. Francesca ci parla di un museo importante che lavora molto secondo il museo di ricerca, secondo il modello di ricerca nei musei in collaborazione con l'università, e Marcello del IFAC CNR di Firenze è qua per rappresentare quella che per me è una vera e un'importante esperienza di coordinazione e di cooperazione internazionale, che è l'IRUG, l'Infrared and Raman User Group, che è un'organizzazione che mi ha sempre, alle cui conferenze e iniziative mi è sempre piaciuto partecipare, proprio perché è nata da un bisogno di scienziati di condividere database, di condividere modalità di analisi specifiche a questo settore. Non voglio portare via troppo tempo, però voglio dare alcuni spunti. Penso che le presentazioni di oggi abbiano sicuramente sottolineato questo punto, che c'è una comunità importantissima di scienziati italiani nei beni culturali all'estero. Questa comunità nasce dalla forza del sistema universitario italiano che, grazie agli esempi di importantissimi mentori, molti dei quali qui presenti, hanno saputo formare una generazione di studenti. Parlando con Sara Abram del Centro di Restauro di Venaria, ho sottolineato l'importanza che ha avuto per me personalmente avere accesso e avere il supporto di questi giovani professionisti italiani, perché hanno mandato avanti la ricerca nel settore. Quindi la mia frase era: bisogna mantenere aperta la fabbrica delle Federiche, che potrebbe essere la fabbrica delle Moniche, delle Francesche, delle Leonore, di tutti questi ricercatori italiani che davvero si stanno facendo un nome. Ma la presenza di noi all'estero è un'importante opportunità anche per il sistema italiano, perché possiamo offrire possibilità di esperienza, di formazione applicata nei musei, quindi completare questo percorso che è qua la ricerca di punta specifica nelle università, portando a magari un contatto più continuo, più quotidiano con i curatori, i conservatori, non che non ci siano in Italia, non che ci siano i cantieri e i progetti applicati, come abbiamo visto. Però queste opportunità per gli studenti italiani ci sono e vorremmo continuare a offrirle. E quello che rimane importante è capire come fare, come possiamo mantenere un dialogo tra noi fuori e le università, i colleghi, i centri di ricerca italiani, perché penso che questo sia il futuro. Quindi le collaborazioni individuali ad hoc sono sempre esistite, bisogna creare qualcosa di duraturo. Abbiamo la Gordon Conference, che si è rivelato un importante appuntamento, ce ne sono altre, mi faccio un po' di pubblicità, a Roma nel luglio 2024 ci sarà l'ICORS 2024, International Conference on Raman Spectroscopy, in cui io sarò l'organizzatore del pannello su arte e archeologia, quindi invito i colleghi a partecipare o contattarmi. Però voglio smettere di parlare per dare la parola appunto ai 4 panellisti e colleghi. Cominciamo da Federica, io tacerò, e poi cercheremo di sollecitare commenti dai colleghi che hanno presentato in modalità remota per concludere la discussione.
Parto io magari condividendo quella che è stata la mia esperienza di rientro dopo 11 anni all'estero. Appunto io sono rientrata con una posizione al Centro Conservazione e Restauro di Venaria un paio di anni fa. In realtà proprio per tutto il bagaglio, diciamo, che mi sono costruita negli anni di esperienza a New York e a Chicago, ho proprio voluto dare la priorità alla creazione di collaborazioni anche con i miei colleghi italiani e non solo, in realtà, che ad oggi lavorano negli Stati Uniti, per cui appunto il progetto che vi ho presentato è un esempio eccellente di questa cosa, nel senso che appunto ritornando in Italia diciamo, ho coinvolto un pochino tutto il team americano coinvolto appunto sul progetto dei tarocchi, nello studio anche delle carte italiane, quindi ho coinvolto la Pinacoteca di Brera, l'Accademia Carrara. Come vi ho mostrato anche in alcune slide della mia presentazione, abbiamo organizzato proprio delle viewings di queste carte italiane presso i laboratori del nostro centro, a cui hanno partecipato appunto anche colleghi sia italiani che anche americani, appunto della Morgan, di Yale e del Met. Quindi sicuramente c'è questa esperienza di collaborazione e questa volontà di continuare a portare avanti collaborazioni con gli scienziati italiani e americani in questo caso per quanto riguarda lo svolgimento di programmi di ricerca. Un'altra cosa che mi viene in mente sicuramente è almeno per istituti come il nostro che pongono un forte accento sull'erogazione di formazione, quindi anche noi come l'Istituto Centrale del Restauro abbiamo una scuola di alta formazione e studio che si propone proprio come obiettivo quello di erogare tutta una serie di proposte di attività di formazione che possono essere scuole, seminari, workshop, conferenze e così via. Quindi appunto un altro fronte che mi ha visto impegnata negli scorsi 2 anni è stato proprio quello di organizzare una serie di corsi di formazione in cui ho coinvolto anche alcuni dei miei colleghi Italian scientist, diciamo, presenti nella giornata di oggi, proprio per condividere il patrimonio di conoscenze che loro hanno potuto acquisire sia grazie alla formazione acquisita nelle università italiane che poi grazie anche alle esperienze di lavoro che hanno potuto affrontare nel loro percorso professionale all'estero. Quindi sicuramente anche l'erogazione di formazione è un fronte importante su cui penso ci possano essere delle opportunità di collaborazioni stabili. Un'altra cosa che sarà molto familiare a Marco, perché appunto ne abbiamo parlato in diverse occasioni, anche la possibilità di organizzare dei programmi di scambio tra istituti italiani e istituti statunitensi. Noi appunto abbiamo pensato appunto ad avviare una fellowship, per ora è una cosa che resta tra i nostri obiettivi, però speriamo di poterla realizzare nei prossimi anni. Una fellowship proprio in compartecipazione tra il CCR e il Met, che dia la possibilità ad un diagnosta formatosi appunto presso le università italiane di trascorrere, diciamo, un periodo sia nei nostri laboratori e poi anche di poter varcare l'oceano e unirsi allo staff appunto di un museo prestigioso come può essere il Metropolitan Museum per acquisire tutta quella parte di conoscenze che forse, come diceva anche qualcuno degli speaker sia di questo pomeriggio che anche di questa mattina, non si avrebbe altrimenti la possibilità di acquisire solo attraverso il percorso di formazione, specialmente in ambito puramente scientifico in Italia. Quindi mi riferisco per esempio a tutta diciamo, l'esperienza museale, quindi per un conservation scientist o uno scienziato puro, quindi qualcuno che come me ha studiato proprio diciamo una disciplina scientifica pura come può essere la chimica, appunto vedere aprirsi le porte di un museo e acquisire tutta quella serie di competenze multidisciplinari che derivano proprio dal rapporto stretto con i restauratori, con gli storici dell'arte e con tutte le altre figure professionali che sono figure chiave nella nostra professione, ecco. Quindi quello che forse mi viene da dire, cioè la cosa su cui mi viene da riflettere è che, come dicevi tu Marco, si tratta però spesso di iniziative magari singole, iniziative che partono dal singolo individuo e che sicuramente abbiamo la necessità di sistematizzare per garantire, insomma, non solo a noi stessi ma anche alle future generazioni una sempre maggior comunicazione, un sempre maggiore aggiornamento e sempre maggiori opportunità in questo campo.
Allora, io mi collego a quello che stavi dicendo tu, Federica. Ho ovviamente diversissima esperienza perché non sono rientrata in Italia ancora, o non so se lo farò in futuro, però sicuramente mi collego all'ultimo punto citato. Io mi sono resa conto, nonostante abbia avuto una formazione chimica per me favolosa a Perugia con i miei prof, e ho avuto la fortuna quando ero a Perugia di girare con i Molab, e quindi ho avuto contatto con tantissimi musei e istituzioni. Sicuramente quello che manca anche in una realtà come Perugia è il contatto proprio giornaliero con conservatori, curators, e penso che questo sia proprio qualcosa che manca adesso nella formazione italiana, perché appunto non c'è la realtà museale vista come la vediamo negli Stati Uniti o in Europa in altri musei. Io ho avuto la fortuna di andare prima a Washington e quindi vivere la realtà del museo della National Gallery, dove per la prima volta mi sono trovata a sedermi con curatori per intere giornate e guardare i risultati scientifici, cosa che non mi era mai successa prima, e credo che questo sia un punto molto importante per le future generazioni di studenti italiani, che ovviamente avranno una base scientifica sicuramente fortissima, ma probabilmente devono essere sensibilizzati su questo aspetto. E io sono molto contenta che ho avuto la possibilità di farlo all'estero, in particolare a Washington, dove credo che anche più del Rijksmuseum dove lavoro adesso il scientist è visto di più. Quindi mi sono trovata a lavorare e magari i nostri risultati erano in un'esibizione o siamo stati coinvolti nella scrittura di cataloghi, cosa che adesso il Rijksmuseum è ancora in via di sviluppo. E credo che il Rijksmuseum, che suppongo sia uno dei musei in Europa più con il Dipartimento di Conservazione e Scienza probabilmente più numeroso, credo che stiamo ancora lavorando su questo punto, cioè di essere partecipi, come diceva Francesca stamattina, co-author con i curatori nella scrittura di cataloghi, o stiamo ancora lottando un po' perché i nostri risultati possano essere visibili nelle esibizioni. Infatti, vedendo anche la presentazione di Federico, mi sono meravigliata quasi e ho pensato di portare queste informazioni con me adesso che torno ad Amsterdam, per cercare di sensibilizzare il museo dove lavoro adesso. E niente, quindi ritornando poi alle collaborazioni e contatti con gli italiani, io in questa fase non sono molto in contatto in realtà con altre realtà italiane, al di là di Perugia, ma perché ci sono cresciuta. E poi credo che è l'Università di Amsterdam, con la quale il museo collabora molto, che ha i contatti più con le università italiane, quindi è più università piuttosto che museo università. Io sono un employee del museo e quindi sono coinvolta lateralmente in alcuni progetti in cui ci sono anche università italiane, ma sicuramente collaboro più con musei di altre country che con università praticamente, quindi l'Italia non è sicuramente una dei paesi e dei gruppi di ricerca con cui collaboro di più, e quindi spero che questo anche possa cambiare e magari appunto che i musei italiani possano essere anche musei più coinvolti sia per la formazione dei nuovi conservation scientist che collaborazioni con altri musei.
Questo microfono. Ok, uso questo microfono. Allora, che dire? Allora, la mia esperienza probabilmente è in qualche modo simile a quella di Federica, in quanto io mi sono trasferita all'estero praticamente subito dopo la laurea, però all'estero ci sono rimasta anche per scelta di rimanerci. Vorrei fare un paio prendere un paio di spunti da quello che hai detto tu, cioè sulla necessità di creare delle opportunità per esempio di scambio tra studenti italiani e studenti americani. Per esempio, quando noi abbiamo finito il nostro ciclo di laurea, che vorrei dire tra parentesi non esiste più a Torino, come nella maggior parte delle università italiane è stato cancellato. Perfetto. Alla fine del nostro percorso formativo esisteva sono 6, beh ce n'erano credo 15 al tempo. A Torino è stato chiuso e per affrontare la stessa tematica uno al momento deve iscriversi a Scienze dei Materiali e trovare un professore disponibile a lavorare nel mondo dei beni culturali, che poi è un po' più la natura dell'istruzione dal punto di vista accademico americano. Comunque, quando il nostro percorso formativo è terminato, c'era questa opportunità che si chiamava Master dei Talenti, che era sponsorizzata dalla fondazione CRT, ed è essenzialmente il modo in cui io sono arrivata al Getty e in cui Eleonora è arrivata e approdata in Francia. Quindi esisteva questa opportunità ed era aperta non solo ai beni culturali, era aperta in generale a molte discipline, ed era proprio con l'intento di creare e di dare la possibilità a giovani laureati di crearsi un network di conoscenze al di fuori dell'ambiente strettamente universitario in cui avevano studiato. Anche questo progetto non esiste più, quindi molti dei progetti che inizialmente erano attivi diciamo 2007, 2008, 2009, con il tempo poi in realtà sono andati, sono finiti probabilmente per mancanza di fondi essenzialmente. O di interesse, sì, è possibile. A tutt'oggi in realtà poi uno può per esempio venire al Getty Conservation Institute e fare la domanda per fare un graduate internship, per esempio è tuttora presente, così come si possono fare domande per fare un postdoc fellow, attività di questo genere. Diciamo che avere uno spazio dedicato a un numero più ristretto di persone, questi essendo studenti italiani, dava più l'opportunità a questi studenti di trovare effettivamente una posizione, perché sennò la competizione è molto più grande. Chiaramente se ci sono 100 domande e 3 posti diventa molto più complicato. Detto questo, questo era il punto di vista che volevo portare avanti. Per quanto riguarda la collaborazione, durante la mia esperienza universitaria, un po' come tutti, insomma, la collaborazione con conservatori, restauratori, storici dell'arte è in qualche modo limitata. Io credo di essere stata particolarmente fortunata in entrambe, sia per il bachelor che per il master. Il professor Piero Mirti, che è stato il mio responsabile di tesi, ci teneva moltissimo che noi avessimo una comunicazione già al tempo con l'archeologo di riferimento e con lo storico dell'arte che si occupava del progetto. Quindi credo che quello sia stato qualcosa che mi ha aiutato molto a capire come potevo comunicare, approcciare la ricerca e spiegare quello che stavo facendo diciamo, a un numero di professionisti che hanno un background diverso. E quindi ricordo per esempio che c'erano alcune terminologie legate alla ceramica che avevano un significato veramente opposto a seconda della persona con cui uno si interfacciava, e noi se ne discuteva moltissimo durante queste conversazioni. Al momento nel mio lavoro, diciamo, quotidiano, su questo sono più vicina a Francesca, nel senso che le collaborazioni con istituzioni italiane sono relativamente limitate. Nonostante questo ho passato tutta l'estate da Federica, che mi ha ospitato tutta l'estate, quindi in realtà sono più limitate ma presenti e sono ben radicate qualora presenti. Sicuramente mi piacerebbe magari sviluppare maggiormente queste collaborazioni con altri enti italiani. Aggiungo, oltre alla Federica, con il Getty lavoriamo molto anche con il Museo Archeologico Nazionale di Napoli, da cui riceviamo circa ogni anno un grosso oggetto in restauro, una grossa opera d'arte, e quindi c'è una buona comunicazione anche con il loro dipartimento di restauro e di storici dell'arte. Lascio la parola a Marcello, dopo questa botta di ottimismo.
Grazie Monica. Mi sembra che collegato in remoto Marcello Lecci, l'attaché culturale del Consolato Generale d'Italia a Chicago, volesse intervenire con un commento. Le do la parola.
Sì, grazie, ma io potevo aspettare prima tutto il giro del tavolo di discussione, intervenire anche dopo se volete, non c'è, diciamo, questa fretta, come preferite.
No, faccia pure, è importante mantenere un ritmo, creare un ritmo dinamico.
Ok, grazie. Intanto grazie per darmi la parola. Io sono Marcella Lecci. Da pochi mesi ho preso servizio presso il Consolato Generale di Chicago come addetto scientifico. Mi sono trasferito dall'Università dell'Aquila dove sono professore di fisica applicata con un ampio, diciamo, su argomenti vari dalla biologia alla medicina all'ambiente, eccetera. Volevo soltanto intervenire brevemente per fornire, intanto per congratularmi per questa iniziativa, è molto interessante, perfettamente organizzata, sia nei tempi che nei modi, e credo che sia su un argomento molto importante per il nostro paese, quindi credo che sia timing. Perché volevo intervenire? Intanto per così, mettere a disposizione quello che è il patrimonio, diciamo, sia di conoscenze che poi di servizi che il Ministero degli Esteri può offrire a voi, soprattutto giovani ricercatori, attraverso la rete degli addetti scientifici. Nel mondo attualmente siamo circa 44, negli Stati Uniti in particolare vi è una rete di addetti scientifici che è pari a 9, distribuiti in varie sedi, 3 a Washington e poi in altre dal nord al sud degli Stati Uniti. Noi facciamo da ponte tra gli scienziati, il mondo della ricerca italiana e il paese dove operiamo. In particolare poi per gli Stati Uniti, siccome viene una rete per l'area di competenza. Io mi occupo del Midwest e quindi a breve avrò modo di conoscere le colleghe che lavorano a Chicago. Era una delle cose che mi ero ripromesso di fare appena preso servizio, ma a breve ci conosceremo se vi fa piacere. Noi facciamo da ponte tra l'Italia e il paese di riferimento e abbiamo pochi strumenti, diciamo, dal punto di vista dei finanziamenti, se è quello che, diciamo, serve a volte, ma abbiamo molti altri strumenti dal punto di vista della rete, delle connessioni tra istituzioni, tra persone, per cui siamo a disposizione per aiutarvi. Il nostro lavoro si inquadra per quanto riguarda gli Stati Uniti, dove diciamo, sono presenti molti ricercatori e ricercatrici che vengono dagli Stati Uniti. Noi ci inseriamo all'interno di un accordo di collaborazione tecnologica e scientifica tra l'Italia e gli Stati Uniti che va molto indietro nel tempo. Il primo accordo è stato firmato nel 1988 e ogni 3 anni vi sono degli accordi di collaborazione che vengono siglati, l'ultimo è stato siglato a gennaio di quest'anno tra i due paesi, che poi aprono delle prospettive di collaborazione ad ampio raggio. Le tematiche a cui al momento l'Italia e gli Stati Uniti danno priorità sono fisse, sono 7 aree scientifiche, non ve le elenco tutte, ma tra queste vi è anche quella che ha a che fare con i materiali avanzati, i nanomateriali. Non vi è purtroppo una tematica specifica per i beni culturali, e questo probabilmente ci si potrebbe lavorare nel futuro, negli anni futuri, interessando il Ministero degli Esteri e l'Accademia dei 40 e tutte le altre istituzioni italiane che possono parlare tra di loro per cercare di capire se di inserire i beni culturali come un argomento strategico per il sistema Paese Italia. Questo riguarda il futuro. Nell'attuale protocollo sono previsti dei progetti di ricerca congiunti e ne sono stati finanziati all'inizio di quest'anno ben 18, che permettono sia di poter svolgere attività di mobilità tra i partner, sono accordi bilaterali, quindi tra due gruppi dei due paesi, e sia anche di svolgere attività di ricerca per materiali di consumo, strumentazione, eccetera. Non sono finanziamenti elevati perché il Ministero degli Esteri non si sostituisce al Ministero dell'Università e della Ricerca, ma permettono di rafforzare diciamo, le collaborazioni tra i due paesi. Quindi su questa cosa, soprattutto i giovani ricercatori e ricercatrici, vi invito a seguire, vi posso dare le informazioni, ma a seguire queste opportunità. Trovate tutto sul sito di Innovitalia, che è il sito della diplomazia scientifica del Ministero degli Esteri. Vi raccomando di registrarvi, perché in questo modo riceverete continuamente newsletter di eventi, di opportunità, di bandi, eccetera. E in questo modo siete continuamente aggiornati. Quindi questo era il primo aspetto che volevo in qualche modo segnalare. Poi mi fa molto piacere apprendere da voi che state vivendo questa esperienza, ma l'ho vissuta prima io. Anche io ho fatto parte qualche anno fa della diaspora degli scienziati italiani, sono stato all'estero per 5 anni, sono rientrato con il rientro dei cervelli, adesso sono riuscito dal nostro paese per mettermi al servizio, quindi il problema della diaspora è molto antico, è molto complesso, sicuramente come paese lo dobbiamo affrontare. Per chi vuole tornare dovremmo fornire sicuramente degli strumenti più forti per poter far sì che dei talenti che si sono formati in Italia e che hanno avuto modo di crescere sia scientificamente, tecnicamente, ma anche come connessioni, relazioni internazionali, se vogliono, e ho sentito che non tutti vogliono necessariamente tornare in Italia perché si trovano bene a lavorare all'estero e vogliono rimanerci, ma questo è un bene perché in questo modo la nostra rete è ancora più rafforzata con italiani che lavorano all'estero e in Italia. Quindi quello della diaspora è sicuramente una tematica molto importante. L'ultimo e terzo punto che volevo trattare è quello di ottimismo relativo al fatto che sino a oggi, per fortuna, il nostro sistema di formazione universitario è molto forte in ambito tecnologico, scientifico, umanistico, lo dimostrate voi. Lo dimostrate voi con le vostre esperienze e lo dimostra la rete di migliaia e migliaia di italiani che lavorano all'estero, in particolare negli Stati Uniti, dove di solito nella stragrande maggioranza dei casi vengono accolte a braccia aperte. Perché? Perché hanno una solida formazione universitaria, perché sono curiosi, perché hanno la capacità di adattarsi, hanno la capacità di inventiva che in qualche modo fa parte della nostra cultura. E questo è stato ribadito praticamente da tutti gli interventi di questa mattina. Chiaramente ci sono delle cose che devono essere rafforzate. Allora, una domanda che pongo ai colleghi magari più senior è finora il nostro sistema di formazione in ambito dei beni culturali è stato molto, molto forte e produce diciamo, delle persone molto apprezzate. La domanda è: cosa dovremmo fare come Paese per continuare a rafforzare nei prossimi 20 anni? Cioè, qual è la domanda che vi faccio? È un po' qual è il modello di formazione che si dovrebbe curare nel nostro Paese affinché si formino delle figure professionali in questo ambito sempre più specializzate, sempre più forti, sempre più internazionali. E quindi questo sarebbe interessante che magari, non so, o in questa occasione o in un'altra occasione ci si ponga questo obiettivo. Naturalmente individuando i vari soggetti, a partire dal mondo accademico, degli enti pubblici di ricerca, dei musei, delle aziende che operano o potrebbero lavorare in questo ambito, in modo da individuare quello che è un profilo e un percorso di formazione. E in particolare direi che, forse è stato citato da qualcuno, dovremmo porci anche la domanda se uno dei canali di sviluppo di queste professioni potrebbe essere collegato con l'attività aziendale, cioè la nascita di start-up e di spin-off che operano nell'ambito dei beni culturali in Italia e poi magari si possono sviluppare all'estero fornendo servizi, perché è chiaro che anche questo aspetto deve diventare un canale di sbocco, perché non si può lavorare tutti, diciamo, in una singola diciamo, ambito. Vi sono tanti ambiti dove la professionalità può svilupparsi e questo forse potrebbe far parte poi anche del percorso di formazione a un'attività aziendale, di management in questo ambito dei beni culturali. Volevo sollevare questi tre diciamo, punti e spero che ci sarà modo di poterne parlare insieme. Grazie per lo spazio che mi avete dato.
Grazie professor Alecci, grazie per essersi collegato e benvenuto nel campo delle scienze per i beni culturali. Voglio dare la parola a Marcello Picollo, rubando 5 minuti dalle conclusioni di Gennaro, per concludere questa tavola rotonda, parlando appunto della tua esperienza, Marcello.
Ti ringrazio Marco. Allora, intanto sono praticamente di un'altra generazione rispetto alle signore qui presenti, quindi cosa mi ricordo? Che negli anni 90 il CNR aveva ancora delle NATO fellowships proprio per il CNR e c'erano anche le senior, e sta di fatto che nel 97 e nel 99, nonostante io fossi ancora un borsista senza contratto al CNR e sotto i 30 anni, abbia avuto la possibilità di vincere le senior, che quello fa già capire quanto all'epoca erano anche considerate all'interno del CNR queste borse, perché all'epoca partecipavo con un curriculum vitae magari con 3 pubblicazioni e accedevo alle senior e mi facevo 2 mesi all'ACMA, dove ho avuto il piacere di conoscerti Marco nel 97, e 2 mesi al MoMA nel 99. E quello è stato per me quello che poi per voi è stato il lavoro, però per me è stata la prima esperienza da geologo che non c'entrava niente con i beni culturali, iniziare a lavorare con una borsa di studio post laurea nei beni culturali con Mauro Bacci, fare tutte robe che mai e poi mai né avevo fatto né avrei pensato di fare, però stare in 2 musei in cui il Conservation Department era parte del museo e c'era il Scientific Department, quindi tutti i giorni era un continuo confrontarsi con curatore, restauratore, e anche se io poi ero, stando 2 mesi, ero praticamente così, il ragazzino che passava lì e ciao ciao, guarda cosa facciamo, ma non rompere le scatole. Però mi è servito un po' per capire come funziona la vita all'interno di un museo, che poi tanto non me ne sono fatto di niente perché essendo all'IFAC non abbiamo una collezione, non abbiamo, il problema penso di quasi tutti i cosiddetti conservation scientist italiani, che di conservation scientist non c'hanno niente perché non hanno collezioni da gestire, a parte quelli che lavorano a Venaria, quelli che lavorano all'opificio e all'ICR e in qualche altro 2 o 3 musei, perché in Italia poi i musei praticamente, e già grazie si hanno il conservation department, cioè che un restauratore già grasso che cola. Ok, questo era l'incipit, no? Quindi non ho mai vissuto all'estero, non mi sono mai spostato all'estero per... In teoria ho rifiutato una posizione all'estero perché in quel momento mi si era aperta finalmente una posizione dove sono ora e ho fatto i miei conti, ho preferito tentare la fortuna e continuare in Italia, mi è andata bene. Però indirettamente il fatto che ho girato tanto gli Stati Uniti quasi come vacanziere, perché andavo lì anche per seguire insomma, la mia compagna all'epoca, ho fatto modo di avere una connessione con tantissimi scientist, perché in qualunque città andavo, la prima cosa che facevo, cercavo di contattare il conservation scientist che ne so, quelli di New York, MoMA, Metropolitan, a Washington, a Los Angeles, eccetera. E infatti a Los Angeles ho avuto il contatto con John Twilly e ho fatto la domanda per andare da lui, al MoMA avevo avuto il contatto con Jim Coddington e sono andato da lui e così via. Ha fatto sì che poi dopo con l'IRUG, quando praticamente l'IRUG, questo Infrared Users Raman Group, che all'inizio era solo Infrared User Group, IR stava per Infrared, non per Infrared Raman, poi nel corso degli anni si è aggiunto anche il Raman, ha fatto sì che sono entrato parte della comunità e ho visto lo sviluppo che è stato esponenziale nei primi 7-8 anni, e ora è praticamente un plateau consolidato, di tantissimi colleghi che lavorano quasi tutti in ambito museale, gli universitari o enti di ricerca, ricercatori di enti di ricerca non sono così tanti, che hanno deciso sin dall'inizio di mettere in condivisione una conoscenza, un patrimonio del singolo laboratorio spettri di riferimento per costruire un database specifico, dato che nei beni culturali i database specifici non esistono, te li devi creare da te. E in tutti questi anni insomma, ho partecipato praticamente a tutte le conferenze, o quasi tutte le conferenze, l'ultima è stata il mese scorso a Tokyo, organizzata da Masahiko Tsukada, che è un carissimo amico, e da Boris Pretzel, che è visiting professor lì, un altro carissimo amico. E c'è stato tutto sommato, nonostante i rincari dei voli, che praticamente costano il 60-70% in più di 2 o 3 anni fa, c'è stata una buona partecipazione. Dal Giappone praticamente nessuno, penso più problemi di lingua, abbastanza dall'Asia, tanti americani, abbastanza europei e italiani uno. Io. Italiani italici, poi italiani un po' sparsi per il mondo, perché in italiani c'era Gianluca stamani, no, che parlava, è italiano, infatti mi dicevano, ma quanti italiani siete? Sì, siamo tanti italiani, ma che viene dall'Italia ci sono solo io, perché poi Danimarca, Stati Uniti, dall'ACMA, poi mi sembra erano 2 o 3, insomma, eravamo in 4 o 5 italiani, però italiano ero solo io. Io ero anche obbligato a esserci, essendo il chair dell'IRUG per Asia e Oceania, quindi vabbè, ero un po' forzato. Però ecco, per dire, c'è la possibilità di creare qualcosa che è praticamente a costo zero, cioè non è un qualcosa che ti fa spendere soldi se non partecipare alle conferenze, però non ti fa neanche prendere soldi, però è un modo per far crescere tantissimo la comunità scientifica e c'è proprio, quando partecipi all'IRUG, c'è l'idea di gruppo, cioè tu puoi venire da qualunque parte del mondo, essere un neofita, essere uno dei primi che ha aderito a questa organizzazione, a questo gruppo di scientist, quasi tutti, per condividere un qualcosa. Ogni tanto, qualche volta eri venuto anche te, Bruno, Costanza, mi ricordo in Austria, a Vienna, cos'era il 2008, Però ecco, la presenza in questo caso, mentre statunitense è veramente massiccia, europea abbastanza, italiana abbastanza scarsa, anche perché chi è dentro il musei o conservation lab, ora potresti esserci te o qualcuno dei tuoi colleghi. L'opificio, quella che organizzai a Firenze, manca poco non volevano neanche venire perché pensavano che, sai, io organizzassi una conferenza internazionale. Poi quando hanno scoperto chi c'era hanno iniziato a mandare gente per invitarli il giorno dopo a vedere l'opificio, e tu ne sai qualcosa. E ICR mai visto nessuno, cioè è un qualcosa che non è, non so, non è consolidato, eccetera. Capita qualche volta che ci siano colleghi universitari o di altri istituti del CNR, però manca, secondo me, questa, è perché non c'è nessuno che lavora nei musei sostanzialmente. E con questo basta, insomma.
Grazie Marcello, grazie alle colleghe e ai colleghi che si sono prestati. Posso passare? Abbiamo qualche commento ancora dagli speaker di questa mattina collegati in remoto? Vedo Federico, Clara, Marta, Gianluca, se volete aggiungere qualcosa a questa conversazione.
C'è un commento di Clara sulla chat che condivido, ma non ho molto da aggiungere, un po' per il tempo che è rimasto, ma anche perché insomma, è abbastanza chiaro che quale sia la situazione, come sia forte, la prima cosa, una cosa che hai già detto tu prima, come sia forte la presenza italiana nel mondo, perché oltre a chi ha partecipato a questa giornata ci sono molti altri colleghi italiani che hanno un ruolo molto importante in musei in giro per il mondo. Sono molti, e un po' grazie forse mi permetto di dire che è un po' grazie all'improvvisazione che hai citato tu, Marco, e anche alla creatività di tutti questi elementi sparsi in giro che si mantengono questi contatti. E forse manca una struttura un pochino più, diciamo, solida e duratura istituzionale. Quindi immagino che sia quella la via che deve essere, insomma, rafforzata per, diciamo, favorire un contatto maggiore, uno scambio maggiore in futuro.
Se posso aggiungere
Certo,
due
Clara.
cose velocemente, avevo scritto un commento nei messaggi per poi rendermi conto che siamo solo noi 5 a leggerlo. Ho semplicemente, sì, come avete detto tutti, la formazione italiana è eccellente e lo vediamo dalle presentazioni di oggi. Quello che manca è un po' l'apertura oltre i confini. Cioè io mi trovo come tanti dei miei colleghi a fare talks nelle università a studenti di triennale, magistrale negli Stati Uniti o magari anche in Inghilterra o in Francia. E perché questo non capita nel nostro paese? A me sarebbe piaciuto come studente sentire che qualcuno portasse la sua esperienza da conservation scientist dall'estero. E sapete in Italia si sa che ci sono tanti italiani che lavorano nei musei, semplicemente chiamateci, mandateci un'email. Noi siamo la comunità dei conservation scientist, è la comunità forse più bella che ci sia al mondo, siamo super collaborativi, ci piace, ci scriviamo, quindi veramente chiamateci e siamo sempre felici di poter portare la nostra esperienza e poter dire agli studenti che sì, potete diventare un conservation scientist, è fattibile, perché è quello che avrei voluto avere io, quindi call us.
Grazie Clara, su questa nota che posso soltanto definire gioiosa e di ottimismo, io passo finalmente il microfono alla persona che con Francesca è il motore di questa iniziativa di oggi e che ci ha sostenuto davvero a spada tratta.
Grazie Marco. Scusatemi, uso l'italiano, anche perché il mio inglese ormai è diventato veramente pessimo, perché non lo utilizzo da molti anni. ma credo che Marica mi possa scusare, a cui rivolgo i miei ringraziamenti innanzitutto. Dunque, devo dire pochissimo, potrei dire pochissimo, diciamo, ecco, questa workshop mi ha entusiasmato, semplicemente mi ha entusiasmato. E devo dire appunto che ha costituito una sorta di svolta in una tradizione che noi avevamo inaugurato nel 2019, in cui praticamente appunto l'Accademia, che ha sempre in qualche maniera valutato con molto favore questo mix di scienze dure, diciamo, ma anche di aspetti che riguardano le humanities, aveva accolto questo mio suggerimento di fare un workshop su metodi innovativi per i beni culturali. E quindi questo è stato nel 2019, abbiamo avuto come relatori appunto Sgamellotti, la Maria Perla Colombini, certamente tutta la parte di gas cromatografia, di pirolisi sviluppata a Pisa, Luigi Campanella, tutta la parte diciamo riguardante i materiali cellulosici, e Piero Baglioni, la scuola di Firenze in qualche maniera. E poi ovviamente Antonio Sgamellotti che ci entusiasmò con le sue escursioni col Molab, e appunto io vi raccontavo un po' gli studi di proteomica. In effetti siamo stati i primi in Italia a introdurre la proteomica nei beni culturali. Il presidente De Concini, il nuovo presidente, mi chiese di rinnovare questa tradizione, aderì con piacere. Avevamo questa seconda edizione, in effetti delle persone posso citare Gilberto Artioli, Francesco Taccetti, ancora la Maria Perla Colombini, Luigia Sabatini, Lela Birolo. Quindi diciamo un po' il panorama che si delineava e si era delineato in Italia dei cultori universitari di chimica dei beni culturali. Quando il Presidente mi ha chiesto di nuovo di pensare alla terza edizione, io ero piuttosto riluttante. In effetti questo però succedeva qualche giorno prima dell'incontro che io ebbi la prima volta che incontrai Francesca ad Ariano Irpino. E mi colpì, diciamo, questa citazione di Francesca, di questo convegno di Roma, che in qualche maniera faceva partire, in definitiva ha fatto partire poi un po' tutte le iniziative scientifiche dei vari musei internazionali. E quindi a questo punto contattai Francesco, contattai Antonio, e quindi è nato questa edizione, questa terza edizione, che io, come ho detto prima, per me rappresenta una chiave di volta. Perché? Abbiamo sentito prima, questa è una comunità, è una bellissima comunità. Allora se l'Accademia è disponibile a ospitare questa comunità, e diciamo offrendo in particolare lo spazio che può offrire sul sito web, quindi si può creare una pagina web specifica, si può utilizzare appunto questo mezzo per riallacciare i contatti, per stabilire nuovi contatti, come diceva qualcuno, per invogliare le nuove generazioni. L'invito a questo convegno è stato mandato a tutti gli studenti dei corsi di laurea di conservazione e restauro dei beni culturali. Spero che molti di loro siano stati in collegamento, certamente ce ne saranno moltissimi che lo guarderanno in streaming. E quindi diciamo, abbiamo creato l'occasione per questo, e quindi l'invito ora un po' a voi di creare un gruppo che fa partire l'iniziativa, e poi eventualmente posso io fare da interfaccia con l'Accademia dei 40, e sono sicuro che questo percorso possa avere un successo. E quindi questa quarta edizione ve la gestite voi, perché secondo me appunto veramente potrebbe essere un momento, diciamo, di ritrovarsi e guardare al futuro, e guardare al futuro in tutti i termini, in tutti i sensi, e quindi di questo sono veramente per questo sono felice, per questo appunto vi dicevo che sono rimasto veramente entusiasmato a questa riunione. Forse ho parlato troppo però finora, però devo sottolineare i ringraziamenti. Dovrei ringraziamenti innanzitutto ai miei due colleghi che con il loro entusiasmo mi hanno consentito la realizzazione di questo bellissimo meeting. Un ringraziamento ovviamente al personale dell'Accademia, ma del personale dell'Accademia un ringraziamento particolare alla dottoressa Trimani. Vorrei che ci fosse un applauso. Giulia è stata efficientissima, come avete molti di voi potuto constatare, e veramente abbiamo avuto il successo organizzativo di questo meeting si deve a Giulia. Quindi, a questo punto non mi resta altro che salutarvi, forse con un arrivederci, scusatemi, ovviamente la parte tecnica è stata anche fondamentale, ma già Antonio Scamellotti aveva sottolineato l'importanza dei collegamenti, ancora di più sarà in previsione di questa attività che andremo a svolgere, e quindi grazie, no, veramente appunto ti ripeto Francesca, io credo che sia stato effettivamente questo entusiasmo comune, diciamo di noi tre, che ha consentito questo successo di questa riunione, e soprattutto posto le basi per il futuro. Guardando al futuro vi saluto e in bocca al lupo a tutti, grazie.